misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put flat earth in its place. Here comes the smackdown.
Welcome everybody to Tuesday Night. I'm your host MCToon, and it's a Wednesday, and I have a rather different one. It's going to be a moderated debate between myself and somebody that has a different idea about gravity. He's not a flat earther though, so I'll put a thing on the screen, and it's moderated by Max, who you may know from the Matters Now channel. How you guys doing?
Hello. Really well. Excited. Good to be back here.
Yeah, glad to have you. So anyway, Max will be moderating. He's got the Zoom call. He's the owner of that, the host of that, and I'll hand it over to him to get us moving here.
All right. Thank you, everyone. Let's go through the format for today. It's the Toons debate format, and I'm going to share the link for you. So if you want to refresh that, but we're going to do 1-minute intros for each. And then Angel is going to do a 10-minute presentation. We will have 3 minutes for Toon to ask clarifying questions, and then give it back to him for 5-minute answering those questions. Then we're going to swap it back. Toon will present for 10 minutes. Angel will have 3 minutes to ask questions, clarifying questions, and then 5 minutes for Toon to answer those questions. And then we'll go into a 30-minute open discussion, followed by a 30-minute Q&A. So get those super chats ready. All right, Angel, when you are ready and start speaking, I will start your 1-minute timer for your intro. Let the folks know at home who you are and a brief introduction of yourself.
Good evening, everybody. My name is Angel. I'm a geocentrist. I have different views in science. I'm not going to be here quoting Bible quotes or nothing like that. I'm going to sit here and provide what I consider facts or evidence, and we're just going to see where the discussion goes. A little background: I'm from Bronx, New York, born and raised. I graduated high school. I didn't finish college. I went for business management. I only went for a semester. I'm not an expert. I'm just a layman, and I'm not going to pretend to be an expert here at all. I'm going to let the facts speak for themselves, and that's it.
All right. Thank you so much. Toon doesn't need introduction, but in the spirit of fairness, would you like to introduce yourself? Or
Sure. I'm MCToon. I run the channel, so a lot of people might know me. But you know, if Angel has this video and you want to mirror it or put it somewhere, they might not know me. So I have spent a lot of my time debating against flat earthers. Angel's not a flat earther, so I appreciate that. We've got that going for him already. I do agree that relativity, our understanding of it, is the best explanation we currently have for the things that relativity covers: movement, gravity, attraction, those kinds of things. And I don't know what else. Oh, I successfully completed middle school. There's my credentials I thought I'd throw out there for everybody. And anyway, I've got all my tabs open and I'm ready to go.
all right. Awesome. So next portion, you, Angel, get 10 minutes to make your case on your idea of gravity, and you will be uninterrupted. And then we'll go into the questions. So whenever you're ready and you start speaking, I will start the timer. So go right ahead. Thank you so much for being here.
Okay. Thank you, everybody. Thank you for letting me be here. So let's start from the beginning. gravity was created by Isaac Newton, right? In 1687, right? F equals ma, force equals mass times acceleration. So Newton came up with the idea that mass attracts mass, and that's where gravity is, okay? And then no one challenged that for 200 years until Albert Einstein came along, okay? And he's credited in 1905 with special relativity, which was actually created by Henry Poincaré in 1898. That's a different story. He said a bend in space-time is what creates gravity. Okay. 9.8 meters per second squared is how fast they say things travel in a vacuum without any air resistance or anything due to gravity. I'm here to say that gravity is nothing more than acceleration, and all the ideas given in general relativity could be disputed. I'm not here to dispute the number itself, 9.8 meters per squared second, squared per second, excuse me. I'm not here to debate that. I'm here to debate what causes that necessarily, or what doesn't cause that. I'm not really sure. I have a few ideas, and we're gonna go through that. Okay. So they came up with F, which is gravity, equals G, which is the gravitational constant, mass over R, which is the distance between the center of mass. The problem with this is gravity speed is instant. So that would be the fastest known force in the universe. That also contradicts special relativity's claim. Okay, so special relativity, Einstein claimed that space is an empty void. And in general relativity, he claimed that space is a substance that could be bent. So that's a contradiction. So one of my questions to Toons, because he said general relativity, so I might have got the answer already, but do you believe in general relativity or special relativity? That might be a important question. If you already answered it, then I apologize. Okay. In this equation, G stands for the gravitational constant. If everyone can't see this, I apologize. Should I hold it closer?
Yeah, you could put a little closer. I made your screen larger so everybody can see you.
Yes.
I'll do it just to help out. I apologize, everybody.
No, it's okay. That's so much better. Thank you.
Also, my handwriting, I apologize for that too. That's why I'm gonna read it out, everybody. All right. Okay. So the gravitational constant isn't constant. And you can look this up. Scientists all the time get different measurements. So how is this equation a law of nature would be my question. Because a law of nature shouldn't be defied. Okay, so I believe gravity is the same thing as acceleration when we break it down. And I'm gonna give an example. So weight, according to mainstream science, W, which is weight, equals mg, which is mass and acceleration due to gravity. G. Force is F equals ma. Force equals mass of an object and acceleration. So I'm no math wizard, and maybe y'all are gonna give me my answers tonight, but I feel like G can get replaced by A when they write these mathematical equations, which would mean gravity is just an acceleration, which an acceleration isn't a force. Is gravity and acceleration interchangeable? Is acceleration a force? So another claim by Einstein is we get our weight due to gravity pulling us down, correct? So my question would be, how does a weightless mass bend space-time? That's my question. And objects also have weight and vacuums. They've done those tests before. You can look them up. Another thing, 0G. Scientists prove that 0G is due to motion and not what they claim, a lack of this force of gravity. So scientists recently discovered a fifth force. At NASA, one of the engineers, he was working on electrostatic propulsion. And he said it was in need of a fifth force, which is an electric force that acts on the center of mass of an object. And he also discovered a new electric field around the Earth. So I'm pondering, does that have anything to do with these forces that are pulling, pushing us down that we're going to discuss? If there's even forces doing that. My reasons for being skeptical of what they claim of gravity. There's a new particle called particle X17, which also requires this fifth force. Is it the same force? I'm not sure. I'm proposing it might be the same thing. And there are engines that defy gravity, what they say gravity is, and some of Newton's laws. Newton's a genius, by the way. I love Newton. I'm going to be trashing Einstein. I'm sorry if y'all like Einstein, but Newton's a genius. I'm sorry, yeah. Electrostatic propulsion, magnetohydrodynamics propulsion, electroaerodynamic propulsion, electrogravitics, lifter technology, gravitator, gravitation, inertial mass reduction devices, levitated optomechanical systems. I'm suggesting gravity isn't necessarily what they're saying. And there's other forces, obviously, that enact on objects, but if gravity is what they're claiming, I don't think these things can necessarily happen the way they explain it, at least. Plus, frequencies, how they affect objects. So when we're talking about equilibrium and stuff like that, we're talking about frequencies. The Hutchinson effect, that's things people don't like to talk about, right? Oh, there's not a lot of evidence on it, not a lot of experiments. But there's something called the Invention Secrecy Act of 1951. So
2 minutes.
The government, oh, okay.
2 minutes.
The government isn't disclosed, I'm sorry, I apologize, y'all. The government doesn't have to disclose any inventions. And inventions come with science and math. So there's knowledge in sciences we're not necessarily privileged to. And I think that's part of my bigger point of we don't necessarily understand what's going on because we might not necessarily have all the science and physics of this universe. And I think that pretty much wraps up the first part of my presentation. And I hope I asked enough questions.
All right, thank you so much for that. Now we're going to give Toon 3 minutes to ask questions, and then you'll get 5 minutes to answer those questions. Right? Let me reset the timer. Toon, whenever you're ready and start speaking, I will start the timer.
Okay. So part of the point of this was to provide a mechanism that explains the magnitude of the downward acceleration. So that would somehow output 9.8 meters per second squared, which is of the approximate sorry, I'm trying to reset the scene here. Anyway, and I did it wrong. Never mind. So anyway, so I was hoping on something that would output 9.8 meters per second squared, because that's what I prepared. So maybe you have something, maybe you don't. If you could do that, if you do. I'm wondering where Einstein claimed that space was empty, but then also claimed that it wasn't. I'm a little not quite understanding that. You said something about the fifth force and a new electric field. I'd love to know more about that. That was kind of a new thing for me. So if you could, I'd love a citation of that, or at least something that we could search for maybe. And we have the live chat. Sometimes they could find things that maybe you're talking about. And then the frequencies and what was the Hutchinson effect or something like that. I'd love to have a little bit of more information on that. So, anyway, yeah, if you could clarify those things a little bit, that'd be good.
All right. Thank you so much. Now, Angel, you have 5 minutes to answer those questions, resetting the timer. Whenever you're ready, go ahead.
Okay. I understand what you're saying, and I do have that prepared in the second part, I guess. I'm explaining geocentrism, how everything creates that force. So I apologize if I didn't get to that right away. When it comes to the fifth force, this is all new information that came from NASA engineer. I could look up his name, as well as the Hutchinson effect. I could get the citations. I would just have to look it up real quick if you're interested in that. And I mean, yeah, I didn't have enough time to get to that portion where explaining the 9.8, which is basically the whole point of this. I apologize, but I wanted to stress what gravity is, right, and what we consider it. And if you consider it a bend in space-time and that's wrong, then we have to reconsider a lot of things, even if these numbers are right. And I thought that was pretty important. So I apologize if I took up all my time with different points on that. Just give me a second to look up the NASA astronaut, please.
Okay.
I'll look that up for you, no problem.
I'll pause the timer for you. In the meantime, if you're here and you haven't done the social thingies, you can take advantage of this time, of this downtime, and do them now. Do the social thingies right there. Like, share, subscribe, send this to a friend, send this to your significant other. Go to the corner, yes, the corner of your street, and you'll subscribe to MCToon Live. And that way we can share the love for the channel. That's my thing. I wanted to do it.
I love it. Thank you, Max.
You are very welcome. And annoying your neighbors that way can get you very far. It helps the channel. It might get you hated in your neighborhood, but I mean, I don't care about that.
Most of my neighbors have no idea that I do this.
I mean, it would be weird if you yourself went and did it. I have no problem in asking other people to do that, but...
Well, Icy Spin in the chat says, Fedora tip, sir. Too smart for me. I think he likes your hat.
Yep. Hats are always a win.
Hats don't work on me. My head is misshapen.
Oh. I do wear hats a lot when I go out, especially if the sun, I'm super like pasty white, and if the sun catches like the top of my head, that's bad. That's really bad.
Do people get blinded?
Yes, pretty much. Yes. You can get blinded in the moonlight with my head. It's so shiny.
But so does it freeze things when it bounces off your head, when the moonlight bounces off your head?
Yes, I've noticed that if I go out at night and there's a full moon, I start getting cold thoughts. Like I think of ice and ice cream and the butts of penguins.
Butts of penguins. Okay, did you found something?
Yeah. As far as the NASA astronaut's name, his name is Charles Bueller. Okay, if you want me, I could send the article to you. and you talk about the fundamental new force.
Okay, that's the fifth force.
Yes. And
All
it
right.
it produces enough thrust to overcome the Earth's gravity without emitting mass. And so, if you want, I could send it to you right now through Facebook.
Sure.
Actually, let me
Sure.
send it to you.
You can use the internal chat here on Zoom. If you see below, there's a bunch of buttons. You can click on chat and send it through there.
Let me see chat. Okay. I'm gonna send it through here. Okay.
All right.
Also, the new particle X17. I'll send that as well. Because the new particle X17 also requires a fifth force, a new force.
Now, I thought that the X17 was a car by Fiat from the early 70s. Does anybody like the Fiat X17 car?
I don't think we have those here.
I'm sending that right now into chat. And then what's the last thing you asked for?
The Hutchinson, the
Oh, you want
Traycation
the
Hutchinson.
effect?
Yeah.
I actually, damn, I have a PDF, but I'm never able to share them to Facebook. I wonder if I could share it here. I got a PDF on this.
You should be able to send the file, yes.
Okay. Yeah, to show these people, because my problem is I'm chock full of information, but I cannot get this stuff straight and organized. Okay, send the file. And I send it to Zoom. No. I could send it to Messenger, actually. I'm going to send it to you in Messenger.
Okay.
All right. I believe there was one more thing we asked for. The electric field on the Earth. So I'll send that to you as well.
Yeah, I got the Trey Hutchinson effect here.
Mm-hmm.
We're a big fan of
So-
Trey Hutchinson.
So when you have the right frequency, you could levitate objects like acoustic levitation. So I don't think there's necessarily a force pushing down on objects, or pulling down. If there's a force, it's possibly pushing it down, and that's through the movement of the celestial bodies. And I'll talk about that in the second half of this.
Okay.
All right. So now we're going to hand it over to MCToon for his 10-minute presentation. I ask you, please, Angel, this part is for him uninterrupted. So he will share some information with us. And MCToon, whenever you're ready, I will start the timer.
Yeah, give me a second. I'm going to prepare the scene here so that they can see you.
No problem.
Yep.
While you do that, everyone, FTFE is on a really big marathon stream, and it has been awesome. I've been watching it a lot while I've been working today. It's been fun. He had a really good conversation with Raichi, so be sure to drop by FTFE's channel, send him some love. He's putting on a great effort to do this, so he should be absolutely commended. Be sure to let him know how awesome he is.
All right. Good timing. I'm ready.
All right.
So, all right. All right. Well, gravity in our reference frame, it manifests as an acceleration, and outside of our reference frame, in the as it pertains to general relativity, which we don't interface with regularly because we're not going fast enough or having enough mass, so it doesn't become necessary to apply that in most cases. So within our reference frame, gravity manifests as a mass attracting mass acceleration. And he already put up the formula on the screen. So I'm going to actually use that formula. As he said there, this is F, the force, equals G m1 m2 over r squared. And then we're going to use that. That's the law of gravitational attraction. And the F equals ma that you mentioned, Angel, is actually the second law of motion. It's a force equals mass times acceleration. So I'm going to, if you use those two together, and when one of the masses is significantly smaller than the other mass, so for example, a human body in comparison to the mass of the Earth, then you can simplify it, and you can use then the mass m in F equals ma to be the mass of the Earth, and the mass of the Earth. Anyway, and then you can simplify the equation there. So you see down here, we've got ma equals g m1 m2 over r squared. Then giving you, because the m would be your mass. That's the m2, right? The smaller one. And so they cancel. And I misspoke earlier. So anyway, that gives you a equals g m1, which would be the mass of the Earth, over r squared. And we know the mass of the Earth through a couple different methods. Then we use on top of that, because the Earth is rotating, we need to include centrifugal acceleration, which is generally upward. It's upward at the equator, and it's varying at different latitudes in its direction. But as you get toward the poles, the magnitude goes to 0, so it doesn't affect you much, even though it's a little bit off vertical. But we're going to use that. I'm not going to do a complicated one. I'm just going to use basically high school algebra here. And that's why I'm not using like sine, cosine to get the angle of it. So those are the equations I'm going to use. The acceleration due to gravity and the acceleration due to centrifugal acceleration. And then I'm going to look at some locations here. So if we look at Kauai, Hawaii, which is somewhat near the equator, and it's at a somewhat high elevation, there has been an IGSN 71 gravity station measurement there several times, so they know very precisely the downward acceleration magnitude there. So we can use then, to predict the amount of the downward acceleration, we can use the elevation, which is 1,130 meters. And that gives us the distance to the center of the mass of the Earth right there. I'm not going to read it out. Then we can also use the tangential speed, which is 1,500 kilometers per hour. Since we're near the equator, it's nearly as fast as you can go on the equator. It doesn't go a whole lot faster. That tangential acceleration will be the centrifugal acceleration moving you out. So step one, we get the gravitational formula. We apply that. We've got the mass of the Earth. We've got the radius at that particular location. Predicting the gravitational acceleration without centrifugal acceleration is 9.80407. Then you take the centrifugal acceleration at that location, and the predicted centrifugal acceleration is 0.02915 approximately. You put those together, you subtract off the centrifugal acceleration, and we get a predicted downward acceleration of 9.77 meters per second squared, the actual measured acceleration. And on this page here, I'll give you this page here, Angel. On this page is the links to all the source materials for where these measurements are housed. So we're off by 1 digit in the third significant figure from the prediction to the measurement. And as I said, I wasn't being highly precise in the prediction. So to be around 1% agreement, or less than 1% off, is very good. Do the same thing for Fortaleza, Brazil, And well, first for International Falls, Minnesota, which is not far from where I am, we get, I'm not going to go through each of the steps, but we get a predicted downward acceleration of 9.819, and we get a measured downward acceleration of 9.808, a difference of 0.01. Again, there we are in the third significant figure is where we have to go before we have a disagreement. So very good, very precise prediction. Same thing in Fortaleza, Brazil. We've got a predicted downward acceleration 9.76 and a measured acceleration 9.78 for a difference of 0.016. So again, we have great agreement in the predictions of the Earth rotating and the Earth having a mass according to the law of gravitational acceleration. So, well, that is my presentation. So if you have any clarifying questions you'd like to ask, I could go over them.
Yeah, I have two questions.
Okay.
One is the equation you gave me, A equals G M1 dash R2. Is the G stand for gravitational constant or acceleration?
The capital G is gravitational acceleration.
Okay. And one of your measurements was at the equator. There's gravitational anomalies at the equator, correct?
Oh, there's gravitational anomalies all over the Earth. But it wasn't at the equator. Fortaleza, Brazil, I think, is the one that's the nearest to the equator.
Okay, the nearest. Okay,
Yeah.
I apologize.
One second, please. Toon, people in the side chat are saying that there's an echo, I think, with Angel's sound.
Fixed it.
Awesome. Thank you so much. Sorry. Go on, please.
Is that better?
Yeah, it was on his side. Don't
Yeah,
worry
it was
about
my fault. Yeah. What was the other one? Just what you're wondering where it was?
I mean, you answered the question. So it's not.
Okay.
It wasn't on the equator. So the question.
Yeah.
It's
Yeah.
fine.
There's gravitational anomalies everywhere. The largest one
Yeah.
is to the west of India in the ocean there. There's a rather large one there. But yeah, that's not surprising that there's gravitational anomalies because there's the distribution of mass within the Earth is non-homogeneous. So, so I guess we don't have a whole lot of clarification to go there.
I'm going to prepare to try to explain how there's no proof for heliocentrism. So we're going to get right into that if that's cool.
Well, yeah. So Max, I think the second portion of it where I present, he asks clarifying questions, and then I do the clarification. I think we're done with that.
All right.
Right.
So we can just go into the 30-minute open discussion. Let's try to be as civil as possible, let each other finish, and in case I need to get in there, just know that I might, if it gets too out of control, which I don't think so. Angel seems very nice, very polite. I'll just mute. So, all right, you can go into the open discussion. Thank you so much.
Okay. So no experiment has ever proved the motion of Earth. Okay. From Airy's failure to Michelson-Morley to Michelson-Gale-Pearson, we could go through scientific analysis and scientific papers of scientists and experts stating this. This isn't my opinion. This is a fact. Geocentrism gets proved every time heliocentrists conduct an experiment to try and prove the Earth moves, because it doesn't. And every piece of fringe shift has proven to be ether. And we could have a whole separate debate on that. Fringe shift is ether. So ether drift is what you're measuring when we're talking about rotation. When we're talking about 15 degrees per hour, we're talking about fringe shift, we're talking about ether drift. Okay? So Mach's principles, I mean, if people want to, take a screenshot, if they really want the math behind this stuff, right? I'll try and simply break it down. But in Mach physics, instead of F equals ma, it's F equals ma plus centrifugal plus Coriolis plus Euler, which are the forces created by the motions of the celestial bodies. And so those are the three inertial forces: Coriolis, centrifugal, and Euler. Okay, these are the components. If y'all screenshotted it. Okay, the centrifugal acceleration creates the Coriolis acceleration. And the Coriolis not only cancels out the centrifugal, but it creates a net centrifugal force. This is the net centrifugal force. This force mimics what we call gravity. Okay. There's something called the axis of evil. We could look it up. The cosmic radiation background.
Okay, let's.
Earth is the
One
center of the
second.
universe.
One second. Let's let MCToon address some of what you've heard right now and keep the axis of evil handy there at the ready, so we can talk about that a little bit later.
Yeah.
Okay.
All right. I'll. So you started by saying that claiming there's no measurements of the motion of the Earth around the sun. So I will. I'll reference here. 1727 publication by James Bradley, where he discovered aberration, where the stars in the north celestial pole had a 20 arc second or 20 and a half arc second circle that they traced in over the course of a year, and the stars on the celestial equator traced a line, and everywhere in between they traced an ellipse. This is due to the composition of the movement of the Earth and the speed of light. This is actually stated in the first sentence of the Michelson-Morley paper. So there's aberration. Number 2, the annual Doppler shift. So as the Earth moves in one direction in one part of the year toward stars, there's a particular color to the light that they measured in 1868. Sorry, no, it wasn't 1868. It was 1892 when Vogel and Schneier published this. And then 6 months later, that light shifted toward the red. And then at halfway points, it was unshifted. So there's an annual shift in the color of light as the Earth moves around the sun. So those two things there are specifically mentioned by Einstein in his 1916 publication called Relativity, This Special and General Theory. He mentioned both of them in chapter 16, where he said, we refer to the yearly movement of that apparent position of fixed stars resulting from the motion of the Earth around the sun, aberration, and to the influence of the radial components of the relative motions of the fixed stars with respect to the Earth on the color of the light reaching us from them. So the very cool thing about this that confirms that the Earth is moving is that these two measurements are orthogonal to each other. They're not in the same direction. So if it's something like ether that is causing it, then why are these motions orthogonal to each other? I would need to know. So, all right.
Oh, sorry, I'm looking up the PDF. As you're saying that, I have a PDF on how stellar aberration is explained through ether. And your second point was redshift and blue shift, which was already proven wrong in an experiment in a lab through plasma redshift, which is tired light, which disproves a lot.
Yeah. So what you're talking about is not the variation of the color shift. You're talking about that's an attempt to address the expansion of the universe redshift. This is specifically about the redshift blue shift variation that's annual.
Yeah, but you're assuming that's a distance thing just because they change colors when it could be a frequency thing. It's the same thing.
No, it's not assuming that it's a distance thing. It's about a motion thing.
Emotion. The
It's
stars
it's
move.
a
The
it's
stars
a
move. Geocentrism says the stars move. I don't see I don't see the dispute. I don't see how that proves the Earth's moving. You're proving the stars move,
I'm sorry.
which
Why would we believe that the stars move? They're in relation to us, and right. Why substitute that in?
the axis of evil exists, and no experiment ever proves motion.
But I cited 2 experiments that prove motion.
Those are what you call interpretations of data, and there's alternative interpretations of data, meaning that if something was a fact, there wouldn't be an alternative version of that data. So you have an explanation based off your preconceived bias of your view, which is okay. But when it comes down to facts, it's not necessarily a fact. So I think people have to keep that in mind.
You have misunderstood the redshift blue shift, and you've attempted to bring in something that's attempting to address the redshift of all stars
and
galaxies.
You try and explain it so I could address it? I don't want to disrespect and not address something that you said.
So the baseline of the measurement is when we're moving orthogonal, or when we're moving laterally in relation to the stars. So I can show you what I mean here. Give me a second. All right, okay. You see my paper here?
Yes.
All right, so we'll put the sun in the middle. We'll take a top view of the solar system here.
Mm-hmm.
Okay. All right, and then we've got the, we'll put the Earth in 4 different positions, not to scale. And then the orbit of the Earth, right. All right, so there's the solar system with the Earth moving around the sun. Now we've got light coming in from a star here, right? And let's see which way. Oh, no, I don't. Which way is there? All right. Apologies, astronomers, if I'm getting this wrong. Let's say maybe this is a bottom view, or but which way's top and which is bottom, people? Should be north and south, really. So let's say the Earth is moving this direction here, okay? And then at this time of year, it's moving laterally, right? So we've got the light coming into all of these, the same light from the same stars coming into all these positions. And when the Earth is here moving toward the light, it's going to have a Doppler shift one direction, and then 6 months later, when the Earth is moving away, there's going to be a Doppler shift the other direction. And then when it's here and here, this is the baseline, right? So there's no moving toward or away Doppler shift. So the question then is, if you say the Earth is not moving, then why at this time of year is there a shift toward blue? And then this time of year, 6 months later, a shift toward red, while simultaneously, we'll say that there's a orange light coming from another star, right? We've got another star sending light here, right? And these stars at this time of year are not shifted. And at this time of year, they're shifted red, and this time of year, they're shifted blue. So the light from the yellow star and the orange star are 90 degrees off of each other. So why is all of that happening at the same time? And of course, all of the different directions, you can extend that.
Why is a good question. I don't know, but I know for sure that the color of the star doesn't determine its motion closer to you or farther from you.
I didn't claim it has anything to do with how close or far we are in this instance.
Right, but you're saying because the Earth is moving, when it's moving in this direction, the light is this color, and when it's moving the other direction, it's this color. And what I'm saying is motion has nothing to do with colors and frequencies. Frequencies have to do with vibration.
Are you saying that the Doppler effect doesn't exist?
I'm saying it's not what they're saying it is, because that's not how light works. Tired light disproves the stars being closer or farther us.
It's not the topic. It's not the topic.
Color.
So then my question to you
That's
is,
what that is.
why?
That's what you're saying, is our motion is due to our motion is causing one star to be one color when we're moving towards it, and the other to be a different color when we move away. That's the same thing as saying if the star was moving closer to us, or it's the same thing. You're saying if a star is moving closer or we're moving closer to it, it's one color, or if it's moving away or we're moving away, it's one color. Redshift and blue shift doesn't have to do with the star's direction or the Earth's direction of its movement. And if it does have to do with the direction of the star and how it's moving, it would be a change of frequency or vibration, because that's how nature works.
So
I know
a change in frequency?
Yes.
A change in frequency is a change in color in light. You get that, right? Okay. I just want to make sure I wasn't misunderstanding you. So yeah, so what you're saying is that the light at this time of the year, the light coming to us from yellow star, for some reason is tired, and then 6 months later, for some reason, the light is less tired. Is that what you're saying?
Well, I'm saying based off your cosmology and the inverse square law, that light from that star can't even reach us, number one. So I'm not even sure.
It has nothing to do with this topic at all.
What a star is, how far, none of this. So we're trying to do our best as humans to explain these phenomena that we see.
Okay. None of that matters. It doesn't matter how far away we are from it. It doesn't matter what it's made of.
I'm gonna make it make sense. Yeah, it does.
What does matter is the fact that the light coming to us from this star is blue shifted at this time of year, not shifted this time of year, and red shifted this time of year. The light coming from the orange star, the orange line here, is red shifted here, blue shifted here, and not shifted on these two spots. So it can't be tired light, because why would the light be tired, more tired here than here for this star's light? And but 3 months shifted, it's more tired here and less tired here. That doesn't make any sense.
No, I see what you're saying, and that might be me misexplaining myself. So let me re-explain myself. I'm not saying that's tired light. I'm saying plasma redshift being proved in the laboratory proved that the color of the light isn't the star moving or the Earth moving. So I'm not saying that light that's hitting us is tired or not. That's not what I'm saying. I hope that clarifies my position a little bit.
Well, all you've done is say it doesn't do it. So I'm asking, well, what causes this then?
See, and like I said, I'm just a layman. I don't have the answers, but
so then why?
Not a fact, and it's just an interpretation of data. Then we're allowed to have alternative views, or we're not. We can't say this is a fact, because you said the Earth rotates and it moves because of this. And if that's not a fact, then how are you presenting it as evidence? It's just an interpretation of data.
But you don't have an interpretation of data at all to refute it. All you have so far is said, I don't like it, therefore I'm going to reject it.
That doesn't add any credibility to that at all.
It doesn't remove any credibility either.
Yes, it does.
All you have is denial. Denial is not evidence.
Denial. What? I have evidence that in a laboratory they did an experiment saying the color has nothing to do with movement, and you're saying that the Earth moving changes the colors of the stars, and you're presenting it as evidence.
Angel,
that's what you're doing.
Your attempted one, which it'd be good if you posted that, but I think I know what you're talking about. The one you're talking about is about the redshift of all of the stars in general, with the ones that appear to be farther away being more redshifted. That's what you're attempting to do. That doesn't have anything to do with this particular one where the shift is seasonal.
Because you're still saying that if a star moves towards us or away from us determines the color, red, shift, or blue.
It shifts the color. It doesn't determine the color.
That's already been disproven in a laboratory through experiment. So why am I going to go against the scientific method?
Because
with an
first of all,
interpretation of data to fit a model.
Because as I said, and you seem to not understand this, the experiment that you're talking about isn't about this type of shift. It's not about this type of shift. It's about the redshift of all light, and more redshift as they're farther away. Now, I don't agree with the experiment if I'm remembering the one that you haven't yet sent. I'd love it if you sent it. Right?
There's more than one experiment. Let me look through my files. But the color of the star has no influence on what direction is moving or any of that. And if it does,
so it sounds like you're denying.
Moving closer backward.
Sounds like you're denying that
based off an experiment in a lab. I mean, okay, denying.
Yeah, you're denying that Doppler shift exists for light, which has been measured in a lab. So that's a bit of a stretch.
That's a whole different topic that we could actually compare evidence.
No, that's my exact topic.
See what's
That's the exact topic.
Our exact topic right now?
Yeah, our exact topic is whether or not light has a Doppler effect when the receiving object is moving. And yeah, to deny that is a bit of a stretch. I mean, that's going to be a really high bar, that the Doppler effect doesn't exist.
I think I will make a moderation decision because we got deep into the Doppler shift. I think we should steer it back. And I know, Angel, that you said that you could provide your evidence for the magnitude value of gravity. I think that was the original topic, and we've covered this. If you would like to share that link so we can share it with the audience, but I would like to get us into that specific thing.
Yeah, I'm sharing it right now. Sharing it right now in a Facebook Toon right now.
Okay.
All right, I paused the timer, and while we get that link over, SimKLA asks if you, Angel, have a channel, or where can people find you?
I'm thinking about making a channel. If I do a channel, I'm gonna do more spiritual science. I'm not gonna do this type of science. I actually told myself I wouldn't do these type of debates, but I was challenged and I just did it. I have no background in this type of stuff at all. I've just been debating people for like 15 years, getting smashed, and just learning through that. Like, learning that you can't just Google something and read a title, that you have to read these scientific papers and like actually do your own research to be like well-versed in these topics. And this is just another learning experience for me. That's all I was really here to gain. I wasn't here to gain followers or money or anything at all.
All right. So let's get into the topic of the 9.8 meters per second squared. All right. And I will start the timer. You can go, Angel.
I have no debate of the actual equation itself. It exists. It doesn't include air resistance, but when you start adding all those factors in, you can get the measurements. But all that is acceleration. And we're saying due to what? And I'm saying due to the movement of the celestial bodies in the universe. And how do we know we're the center of the universe? The axis of evil, which the cosmic radiation background already prove that we're the center of the whole universe.
Why do you think that
Mm-hmm.
establishes anything?
It says it itself. You can look it up.
I have looked it up.
Through the radiation.
I'd like you to explain it for the audience, since it's your claim. Right.
It's not my claim. It's anything anyone could look up. It's general information that's already proven. I'm not here to make any claims. But
no, you literally did just make a claim.
If you want to know what was supposed to happen based off their cosmology, the Big Bang cosmology, when they did the CMB, the radiation was supposed to be more spread out and random, and there's spots that it actually looks very structured. And through that structure, we're the center of it all. They claim that at any point in the universe, you would seem like the center because of expansion.
Can you cite the paper that concludes that the CMB and the axis of evil proves that the Earth is not moving?
I'll just send it. You could prove the Earth is not moving by just citing any experiment ever to prove its rotation, to be honest. But,
well,
okay.
Except for, Bradley, 1727.
Definitely not Bradley.
Vogelschneier.
Definitely not Bradley. That's all fringe shift. That's all.
Bradley's not fringe shift.
If that's the case, Brian Cox wouldn't and Einstein wouldn't be up there saying that there's no experiment that could prove Earth's motion.
But you just lied. Hold on a second. Hold on. I'm gonna. I don't like that you're lying. Right here. What? Right here.
I'll send you the video.
Do you see this? I have the book.
Hold on, Angel.
I have the book right here. We're looking at. You see it?
What book?
You see the book? Right. I don't know if it did. I shift my. I shift my camera. Can you see it?
Yes, we're seeing it.
Okay. This is Einstein's book. These are Einstein's words. How do we know that the Earth is moving? We refer to the yearly movement of the apparent position of the fixed stars resulting from the motion of the Earth around the sun. This is Einstein right here. These are his words. So when you say something about Einstein, you make a claim. I've got the book right here. This is the book that he wrote. So you don't get to claim that Einstein didn't say this when I have it right here. Okay? So then, also he says, and to the influence of the radial components of the relative motions of the fixed stars with respect to the Earth and the color of the light reaching us from them. So Einstein himself said that we definitely do know that the Earth is moving. And he cited two of the experiments. Right there. Relativity. Albert Einstein. Right there. He wrote this book. That's who wrote this book. All right.
Einstein also said the mathematics works for both the Earth being the fixed point and the sun being the fixed point. So those are just mathematical equations that he cited his opinion on. But
cool. Well, the difference is that I have his actual words right here, where he specifically said that's how we know the Earth is moving.
I have his words right here. I have his words right here.
Okay, citation, please.
Okay. And then let me send it. I'm not even gonna say it. I'm gonna just send it. I just send it right now. Hold on. Oops.
While we do that, we're coming up on the end. So people in the audience, get your super chat ready. We will be answering questions after we are done with the open discussion portion of the debate. Thank you everyone for being here. And we will get the link shortly. Let us know when you have sent.
Yeah. I have the
loading. I couldn't get the full quote in with the screenshot, but it says in 1922, Albert Einstein gave this speech, right? And this is his quote. Since then, I have come to believe that the motion of Earth cannot be detected by any optical experiment, right? Though the Earth is moving around the sun. And then I could show you videos because I got them on my Facebook in the same Flat Earth channel. I only got a few posts, and a few of those posts are Brian Cox saying that no laser gyroscope, no pendulum, no nothing has ever proved the motion of Earth.
Okay, so let me address this here.
Scientists...
I can address this here. So this quote right here says the idea about the motion of the Earth with respect to ether is incorrect. If we admit Michelson's null result as a fact, this was the first path that led me to the special theory of relativity. Since then, so the Michelson's experiment is the Michelson-Morley experiment. That is an optical experiment that is terrestrial, and that's an important thing. A terrestrial experiment. So when he says, since then I've come to believe that the motion of the Earth cannot be detected by any optical experiment, he's specifically referring back to the previous sentence there about Michelson, about that type of experiment, not about the ones that he mentioned in this book here in 1916 about. So he's not in this statement. In this statement here, he is not discarding 1727 Bradley or Vogel and Schneier. He's not discarding that. He's talking about a specific classification of experiment. Now, the problem with this quote you have here, this quote was given in what language? What language was this speech given in?
It was Einstein. It's German.
Yep. And then who? What was it recorded in?
What do you mean? What was it recorded?
Well, it was in 1922. So the speech he gave was then transcribed to paper in what language?
You asking what language did they translate German into? Would be English, right?
I'm asking you because you brought this up. What language was this speech written down in 1922?
I don't know.
Japanese. Was it transcribed immediately during the presentation?
Assuming by your tone, I'm guessing not.
It was not, in fact. So it was given by Einstein at a speech in German, and then later, not at the same time, written down in Japanese, then translated to English. So we've got 3 hops there. We've got from German to Japanese, and from memory, German to Japanese, from memory, Japanese to English. So if you're going to try to be hyper specific about the wording he used there, that's going to be a bit of a stretch there, because that would, and if you're going to suggest that those words that he did not specifically write down and has those layers of interpretation is going to somehow contradict the actual words that he actually wrote down, that's a big stretch.
No. Okay. Even if we scratch that whole sentiment, he has later quotes in his later years about how the Michelson-Morley and Gale Pearson experiments poke holes in his theory, right? And he's unsure of his own. I'll provide. I don't know if we have the time right now. I'll provide you the citations. I don't have to speak.
Angel. Quoting is not an experiment. An experiment is an experiment. So if you want evidence, quotes are not evidence. Evidence is evidence. You need to actually have the evidence.
So I'll provide links on how the Bradley experiment doesn't prove what you're saying. I could provide Albert Michelson's own paper called The Relative Motion of Earth in the Ether, where he describes measuring ether in his own experiment, where people say they didn't measure ether. In his own words, he says it. You could look up that paper. So
which
when
paper?
we talk about drag and fringe shift and all these things, those aren't evidence of rotation.
Do you mean his 1887 paper?
Yes.
On the relative motion of the Earth in the luminiferous ether? That one?
Yeah.
Okay.
Yes.
So yeah, I got it. Let's pull it up right now.
But he explains that it's because of Earth's rotation.
Here,
right? That was his assumption.
No.
And then when the Michelson-Gale Pearson experiment happened.
No, let's hold it. We got it right now. It's right here on the screen. All right. The discovery of the aberration of light, that would be James Bradley, 1727, was soon followed by an explanation according to the emission theory. The effect was attributed to the simple composition of the velocity of light with the velocity of the Earth in its orbit. So you don't get to say that Michelson didn't agree that the Earth was moving around the sun.
We don't care about belief.
You don't get to You don't get to
We don't
say
care
that.
about belief.
I know. You don't get to say that somehow this experiment contradicts the movement of the Earth around the sun, because that's
It
not
proves
what this was doing.
ether. It doesn't prove its rotation of the Earth.
This in
That's all I
fact
was
doesn't
saying.
prove ether. Michelson was
He said
rather
it himself that he measured
Michelson
ether.
was rather sad about this experiment because he didn't agree with it. But there was a null result on this. This did not prove ether.
A null
This
based on heliocentric.
contradicted the ether.
No, it didn't.
So
It contradicted the luminous ether. It didn't contradict ether.
All right, so here is and the scale here. You have to remember this scale is very much off. These sine waves, the dashed lines here, are the predicted amount of fringe shift according to the speed the Earth was moving around the sun. But
According to what they believe.
But no, it was already measured. But the scale of the dashed line needs to be multiplied by 8. So these dashed lines are actually 8 times higher than this. So these little zigzags on the bottom here are the measured values, and they don't agree with the zigzags here, and that's part of the reason why they're like this was a null. So if you look at the bottom one, you've got the left side. Some of the measurements were below 0 instead of above 0. So it didn't coincide. And of course,
negative drag happens in space too.
So further,
that would make sense.
Yeah, but further measurements of the same thing had the same with higher precision, had much better resolution since then. In fact, millions of times more resolution than they had in 1887. So.
Right. That makes time. So I have one question I will allow myself before we dive into the Q&A. Everyone in the audience, be sure to send in super chats if you would like to ask MCToon or Angel some questions. I have one question. When you were talking about tired light, Angel, do you mean as in the paper that came out recently from Gupta?
That's what I was referring to, but there's other papers. Older one, I believe, like 2018.
So I have the one you sent.
Yeah, that's a newer one.
So right here,
that's not the one I was personally referring to.
So you sent this April 2013 from Florentine Smartdashi, something like that. So this was the one that you said was an experiment that proved redshift, blue shift was not.
No. That's an older experiment. I was sending this because of our conversation about Doppler effect, and I was showing how that does affect the Doppler effect. So I just wanted to.
But this isn't an experiment. This is a proposal.
Right, that's fine.
This is so you can't.
But that wasn't.
So you can't cite this as proof or disproof of anything. This is a guy saying, "Hey, I'd like to do this experiment." That's it. He didn't do it.
Right.
This isn't an experiment. I'm kind of confused why you sent this.
I didn't say that's a fact. I'm saying the plasma redshift, and I didn't share that paper. It's from 2018. If I'll get time, I'll share it. I don't know if we have time right now, and that's where I failed. But I'm saying that light changing colors doesn't have to do with Earth's movement, and we've never measured Earth's movement ever.
But denialism doesn't make it go away.
That's been my case. If which we could say Doppler effect, that's a real thing, which it probably is. Just I have a misinterpretation of what it is because I don't understand it fully. That might be the case, which is fine.
I agree with you there.
That would not have to do with Earth's motion. And I want to readdress that with you sometime so that we could have that discussion further. Right now, I'm going to have to say I don't know, which you could obviously say I lost that, which is fine. But I haven't seen any evidence of a star changing color, anything changing color having to do with anything other than like frequencies or change in mediums, stuff like that.
That's
And
literally
that's not the Earth.
the color.
There's nothing to show
The
the
star.
Earth's movement.
Hold on.
I'm saying the star's moving.
The stars changing color is literally about frequencies. That's what it's about. And then you said it's
if the star hits the medium, because the interstellar medium is plasma, right? Liquid plasma, and you're doing all these damn moves.
not liquid plasma. Angel, there's no such.
Interstellar medium
There's no such thing. There's no such thing as liquid plasma.
Look up the interstellar medium.
There is no such thing as liquid plasma. They are.
What is your blood?
Oh my gosh. Oh my gosh.
That's not the type of liquid plasma I'm talking about. But what are you talking about? There's no liquid plasma.
We're talking
about charged ionized gases.
That's not liquid. That's not liquid.
That is.
It's
why
not.
do satellites use fluid dynamics?
Oh my gosh. Because gas is a fluid.
They use geocentric orbits.
Gas is a fluid. Plasma is a fluid. Water is a fluid. But gas is not a liquid. Plasma is not a liquid.
Fluid,
and your blood plasma.
Fluid. Plasma fluid.
Your
you're right.
Blood plasma is not in space.
Yes, a fluid plasma. Yes, that's what I meant to say. You're right. I used the wrong terminology. I'm sorry. You're right. No, you're right.
Very good.
A fluid plasma. When the star is rotating, and we talk about fluid plasma, we're not talking about empty void. It's going to shift in frequency. There's different forces going around in different places. So if the star's here and the star's here, the space isn't the same. So I don't understand.
I agree.
I don't understand. And maybe it's not up to me to understand. I said I'm a layman. So it's not up to me to understand, perhaps.
I believe you. Yeah. So, which, all right. Which one are you talking about that was the redshift and the tired light?
I gotta look through my PDFs. I've been looking and I cannot find it specifically. Let me look through my. Hold on.
Because all of the ones that I've seen,
okay, and
I've not seen them all, but all of the ones that I've seen are not actual experiments in labs.
Oh, by Lyndon Ashmore. Intrinsic plasma redshifts now reproduced in the laboratory. You can download that PDF.
All right. Oh, it's from vixra.org.
I don't know where I downloaded it from.
All right. You're not familiar with Vixra. That's okay.
No, I got different websites I download PDFs from.
Yeah, where do you get them from?
Anywhere, I just download it. When you look it up, when you send the search bar, you just download it. Okay. There's different websites.
All right, I got that. We'll have to review that later. That's a good one. Are you a fan of Sungenis?
I'm not a fan of him. I've seen his video though.
Which video?
I've seen his video on Einstein, the closet geocentrist. I've seen his video on modern day physics with geocentrism. That's about it. I haven't seen nothing else.
All right. So you mentioned earlier also the Good by Gravity, new propulsion. This was kind of funny too. I'll put this up for people to see here. It's from a securities website, securities.io. So it's not a science website. It's about investment. And Good by Gravity have new propulsion drives just broken physics ? And the answer to often, almost all the time when they ask a question in a title like this, a clickbait title, the answer is almost always no. It's not a hard rule, but anyway, it doesn't. This doesn't actually go over any things. It just makes some vague passing references and then does not include any links to the source materials. But it does, in fact, then at the end give links to companies that might be affected by it so that you can know how to adjust your financial prospecting in relation to this. So you can look at Northrop Grumman there, or IHI Corporation. So if you want to invest in them, right? And then so it really has very little to do with the actual science of it. And of course, this picture here is looks like it's from a nice, fun game. So anyway, we're on to the questions from the audience. Sorry, Max, I was getting off track there, and you're trying to get me back on. All right, I'll see if we got some here. We got, if you want to ask, if you don't want to do a super chat, also just tag me. I'll or tag Max at MXXXD. Tag him, and he'll read them. But I've got some here from FTFE says, I stand with Toon, which is from the guy from Monday Night. Thank you, Craig. Kango44 says, I know nothing about the anatomy of the heart, so can I go debate the heart surgeon and challenge what they know because I know F all?
Sure you can. Yes.
I think that was for Max, not for Max. I mean, it's for Angel.
I didn't say I was the expert. I never claimed it.
But it sounds like you want to debate against it with people that know it.
I'm citing scientific papers from other people,
but you didn't.
Other experts, other scientists. At no point did I make my own claims besides for the Doppler effect, redshift, which is still frequency in science. So
yeah, I totally agree with that. It's frequency. Doppler shift is frequency.
Right.
Yeah. So does, and Vogel and Schneier agree with that as well, and so does Einstein.
Right.
Yeah.
Right.
We all agree.
That's cool.
So that
Einstein didn't even come up with half of his work. I mean, we could walk through Einstein
it doesn't falsify
in the 3 books that they got on him.
It doesn't falsify anything to say he isn't the one that came up with it, right?
No, that's fine.
That's how science works. If I use the Pythagorean theorem to do science, does that mean that I plagiarized Pythagoras? It does not.
No.
Can I use the Pythagorean theorem and not cite Pythagoras and not be plagiarism? Yep, I can. So if Einstein used Poincaré, or if he used Maxwell, which he did, or if he used Riemann or Lorentz or Fitzgerald, any of those people, those were the people on whose shoulders he was standing. That's how science works. And since then, other people have made advancements based on Einstein. The people that figured out quantum mechanics, they did a lot of their things based on what Einstein had put forward in special theory of relativity. That doesn't mean that they plagiarized him or plagiarized the people that he stood upon their shoulders. That's not how science works. So just saying it was plagiarized isn't actually a thing.
You want to go through the timeline?
It doesn't matter.
See what plagiarism is or isn't?
It doesn't matter. It
don't matter.
It's not. That's not how science works. All of science is relying on something that somebody else did before. Einstein was the one that put all the puzzle pieces together. The puzzle pieces, many of them made by other people. Yep. Doesn't change that he put it together, and it doesn't change the accuracy of his predictions and the measurements that match his predictions.
At no point, no experiment proved that the Earth moves, and all your
I'm sorry, I don't have the same religion. I don't have the same religion that you do.
What religion is that?
The religion that you keep saying that all of these experiments that I cited, you just say nuh-uh to. And you didn't provide it. You haven't yet provided any mechanism.
To Earth's rotation, they could be chalked up to different alternatives.
It's not rotation, orbit, different things.
Orbit,
right?
Orbit. So why don't we feel the Earth move then? If we orbit, right? Because we're gonna say constant motion, right? So what is perigee and what is apogee then? So why don't we feel the Earth move?
But what is the variation from perigee to apogee in the acceleration?
Doesn't matter. We're moving at 66,000 miles an hour.
What is the
a shift? 1% is going. We're gonna feel it.
Okay. Well, what's the magnitude of that shift on a second by second basis, and what is the human perception ability to measure that change?
Oh, I know.
What is it, Max?
Humans can feel about a 0.2 meters per second shift in acceleration.
But it's actually worse than that, Max. It's worse than that because in orbit, the centrifugal acceleration and the centripetal acceleration are in equilibrium. So there's zero net acceleration on you. So there's exactly zero force that you could feel. There's no feeling possible because they're equal.
That's not true. That's not true. All right.
Oh, well, educate us on it.
The Earth's rotation isn't felt because of constant velocity, right?
Now, orbit, not rotation, is what we're talking about.
So we feel rotation?
I was talking about orbit, and you keep saying rotation. Why do you keep swapping that?
Because both cause motion that you're saying we don't feel because they're constantly spinning at a constant rate, correct?
All right. Which topic are we talking about? Let's pick the topic and stick to it. Orbit.
We're talking about your proofs.
Orbit.
We're talking about you're saying the Earth moves.
About
so I'm saying if
orbit.
it moves, we have to feel certain effects because we're spinning and orbiting, which are two different motions.
Exactly.
And
yes.
Because, and I'll give you a good example. It's a carnival ride. It's called the uproar. Okay. It spins like this and it moves forward and back. Okay. And according to physics, the only place where you won't feel the constant velocity is the middle. Are we in the middle of the Earth, or we are on the surface?
So all right. So which topic are you talking about here? Are you trying to talk about the Earth's daily rotation, the centrifugal acceleration?
I'm saying.
Saying. Which force are you trying to address here? Centrifugal acceleration?
Both.
Listen, just pick one and then we'll talk about it. Can you just pick one?
I'm going to say it again. You're saying the Earth rotates and orbits, right? And I'm wrong. And Einstein is right.
Yes.
Everyone's wrong. I'm an idiot. Cool.
Yeah.
So if that's the case, right? So now we're here. If that's the case, right? Why don't we feel it when there's two motions going on and we have this device? It's called an uproar, where it spins and moves forward and backwards. The two motions, right? Orbit and motion. And the only place, according to physics, where you won't feel the constant velocity is the center.
All right, show me the physics.
No human
show me the physics.
is in the center of the Earth.
Show me the physics.
So my question is, why don't we feel that?
Show me the physics. You've made the claim that physics makes a claim. I'd like to see that physics.
It's called the uproar. It's called the uproar. Look at that.
That's a carnival ride. Absolutely great. And so I'd like you to apply the physics to the rotation of the Earth and the orbit of the Earth, please. Show. Just walk us through this on your whiteboard there.
I am not in the mathematical capability to do that.
But you made a very specific mathematical claim, and I'd like to see you back up.
You're claiming the Earth rotates. So
no, you made.
Based off physics,
you put
why
on.
Don't we feel it?
Oh, Angel, you put on me a claim.
You're asking me
you
to do
said.
An equation.
You said.
Angel, hold on.
You said.
You asked me to answer my own question.
Hold on, Angel.
You said.
I'm just.
Physics says, and then some things. And so I'm asking you to substantiate your claim that physics says those things. Physics says, this is what you said, right? Physics says that the only place that we should feel nothing is in the center of the Earth. Now, I'd like you to support your claim.
I didn't say the center of the Earth. I said the only place that machine would feel the no, they wouldn't feel the constant velocity. I want to use the right word. I apologize. I'm getting all worked up. I get passionate about these things. The only place you wouldn't feel the constant velocity is in the center of that machine.
Okay, but the Earth isn't that machine, is it? Right? That's not that's not a perfect analog.
How? When it's spinning and moving, just like the Earth would be. It's a pretty close experiment.
Okay, but let's do this. I'll show you what physics actually says. Okay, you've made some claims about what physics would say, but I'll go over what physics actually says in relation to that. So, all right, I'll change my camera so you can see my paper here. All right, so there's two things at play here. We'll do one at a time because it's it's important to isolate them in our analysis of it. So we've got the Earth there, and it's moving. It's rotating once a day. 1 RPD, 1 revolution per day. Okay, that's not very fast, right? I actually have the numbers, and I actually went over them earlier today. So let's put the person at Fortaleza, Brazil. So this is the top view. We've got the North Pole here. This is the equator, right? And then Fortaleza, Brazil is somewhere slightly north of it, right? Not to scale, right there. Okay, so at Fortaleza, Brazil, when the Earth is moving once a day, there's going to be a centrifugal acceleration. Okay. And that amount of acceleration is known because we know the radius. And we know the linear velocity. Right, tangential velocity or linear velocity. So let's see, predicted, we got the tangential speed at Fortaleza is 1670 kilometers per hour, and the radius there is 6366494 meters. Okay, you take those two together and you apply what formula are we going to apply here? The centrifugal acceleration, which is what? You remember that? We covered it earlier. No? All right. That's it right there. We're going to apply that formula to right here, okay, to this point, Fortaleza, Brazil. And the answer is, I'm not going to walk you through the answer, but the amount of acceleration is 0. I've done it ahead of time, of course, 0.00337 meters per second squared. So now the question so you're asking, why don't we feel the 0.00337 meters per second squared outward acceleration? Well, the reason why is because, number one, our bodies don't have that sense, the sense to measure that much, but we do have that ability with gravimeters. They can measure that, and they in fact have. But the other thing is that we do have another 9.8 meters per second squared approximate downward acceleration. So this and this are opposite each other, and they combine together at Fortaleza, Brazil, to have a measured acceleration of 9.78 meters per second squared. So you put this and this together, and you get that. So why don't we feel it? Well, we don't feel it because our bodies lack the ability to feel 0.00337 meters per second squared. We're not that sensitive, but instruments are, and they've measured it. So there, to answer your question about that one. Does that make sense?
Right. The instruments measured drift, the ether drag. Yeah, I got it.
They didn't, but they measured it in complete agreement with the rotation of the Earth and the radius of the Earth. And I've not seen anybody present an ether anything explanation that correctly predicts this magnitude here. Because this amount, this is the measured amount, right? Measured. And my crude prediction was what? Remember? 9.76 meters per second squared. Now, this is my prediction based on gravity and Earth rotating. Now here, I'm going to write down the prediction from all of the geocentrists. I'm going to put it in this box here for the downward, the total downward acceleration. The total downward acceleration from geocentrists. Prediction. Okay. I've studied what other geocentrists have said. I've put together a complete exhaustive list of all of their predictions. And I have them right here. Let me get it. So this is, again, one more time. This is the total downward acceleration predictions from geocentrists. None. No geocentrist has done what I did here, provided a prediction based on their claims about how the downward acceleration will vary all over the surface of the Earth due to whatever thing that they want to say is causing it. None. Absolutely none. Sungenis, nothing. Bennett, nothing. No geocentrist has ever put together that I've ever seen, that a prediction of saying this is what the downward acceleration should be due to Earth being stationary and maybe gravity. I don't know. Different views on gravity. Nothing. And I know you don't have anything. So let me tell you, this doesn't get refuted by saying it could be something else.
I'm not refuting that. Because Einstein said that the math could work for both.
I don't care what Einstein said. I would like you to show me the math that works for both.
I can't. So what you said was a good point. And honestly, that's why I said I don't know from the beginning of this discussion. And honestly, I like to, like, later on, like, provide you with all the ether links that I have and scientific papers and stuff, and then maybe we can have a discussion. Since I'm not an expert, I'd love to see how you dissect that information, and maybe I'll learn something, or maybe you'll learn something. But I feel like I want to know what your opinion is on that now that we had this discussion.
Okay.
I have a couple of questions ready for you, Angel. If you would allow me, MCToon. My mom bakes cakes asked, Angel, if we have a triangle of sides 1, 1, and 1, what are the internal angles?
So what?
We have a triangle with sides 1, 1, and 1. What are the internal angles?
60.
Very good. Thank you so much. William Casillas says, do you think the Michelson-Morley experiment would measure the absolute motion of a train if the train could move fast enough?
I've heard plenty of explanations how the Michelson-Morley experiment is flawed. I like to quote the Gale Pearson experiment more. So to answer his question, I believe it wouldn't. He's probably right about that. I wouldn't put all my marbles in that experiment.
But Michael said Gale Pearson did measure the rotation of the Earth.
They measured friendship.
Yeah, due to the rotation of the Earth. And
which is admittedly, even by Brian Cox, and I'll show you it, that doesn't measure, that isn't rotation. So that's ether drift. And I would like to show you that. You could look on my Facebook, in the page, the flat Earth page, you could click on my profile there, because I don't have that many posts. And 2 of those posts are different videos of Brian Cox saying that same thing in 2 different formats. So it's not like
somebody saying things.
Him.
Here, once again,
this is him.
Somebody's saying things instead of an actual experiment. Okay.
This is Brian Cox, the physicist, saying that.
Wow, he's a physicist.
Yeah, he's a physicist. He's smarter than you and me, probably.
I suspect that you might not quite be understanding what he's talking about in context.
That's
but
fine.
Just for
ears
reference,
don't see me when he says we can't prove Earth's rotation with a gyroscope or a pendulum. So, I mean, when we're talking about ether drift and ether drag,
All right. Next question from Whodunit. You freely admit that you're not an expert in this subject matter, yet you say all experts in this subject matter are wrong. What makes you think you're able to say that?
That's a very good question. And I didn't say that. In fact, everything I was quoting was from other experts and other scientists. And that was my point, or that's what I tried to do, was to not put my opinion into any of this, because my opinion really doesn't matter. Like, when it comes to beliefs and opinions, that should not have anything to do with science at all. So you shouldn't believe me. Anything I say and everything I brought up, you could just look up
you
yourself.
insist.
And that's the point of
You
this.
insist. I will accept that. I will not believe anything you say.
I don't like people to believe what I say. Like, why would you do that? Like, you have a literal walking internet. You could Google anything nowadays. Why would you believe people?
Yeah, definitely. I'll go with experiment. Good idea. By the way, here, if I can make a recommendation for a book that I've read twice, if you count listening to the audiobook as reading it, a book called Why Does E Equals MC Squared and Why Should We Care by Brian Cox. Great book. Definitely.
I do count listening to an audiobook as reading the book, because I do a lot of that. Because, you know, while I work, I'm doing stuff on the computer. I can just play a book the same way I can watch a video. So it's, if I would use that time to read, I couldn't work. So I think it's a good option. Some people don't like it. I do.
I was looking, I was digging around on the floor because I thought I might have a copy of the physical book, but I don't have a copy of the physical book. I only have the audio book.
So should we continue with some super chats? I know we have some questions for him.
FTFE says, so FTFE, do you know FTFE? Fight the Flat Earth? A friend of mine, he fights the Flat Earth. He says he can be a little tough sometimes, so thick skin. He says, when God was giving out brains, Angel thought he said trains and asked for the slow one. Craig, very naughty. Angel's train is not the slow one. PhD Tony. PhD Tony, you may recognize from his name as a PhD. He says, reading and properly understanding scientific papers requires significant skill and background education. It is not something lay people can do.
Yep.
I guess just a comment, not a question. Coriolis Sniper says, my rifle shows Earth motion, my latitude direction. What do you have to say about that, Angel?
The Coriolis is due to the rotation of the stars, and whatever relative hemisphere you're in, I understand that it spins in opposite directions.
And what empirical evidence is there that the rotation of the stars has some impact?
Well, I mean, Mach has, his principles that Einstein used in his relativity. So, I mean, there's that to start with.
The Machian principle is a hypothesis. So I'm asking, when was it empirically confirmed?
So Einstein used a hypothesis in his...
Of course he did. Yes, that's what you do. When you're
so
putting together...
So what's the problem with it then?
The Machian principle has not been empirically confirmed. That's why. That's what's wrong with it. So just saying,
so every
Einstein
experiment of heliocentrism, it's not confirmed that everything spins around us when we see it that way.
Except that all of the things that I've already cited that you haven't refuted.
Interpretations of data versus experiments.
And let me remind you what PhD Tony said.
Method.
Reading and properly understanding scientific papers requires significant skill and background education.
That sounds like trust.
It is not something lay people can do.
That sounds like trust. There's alternative versions of science. Scientists don't agree with each other. The fact that you would say, oh, I just believe it because it's a scientist is the dumbest shit.
I don't say that.
Excuse me, if I could curse here.
I don't say that.
Oh, I apologize.
I'm not the one saying that, Angel.
No, whoever said that is, I can't even converse with people like that. It gets me worked up.
All right.
Just
all right.
define science and then say that to yourself. Read that question again, then define science and then slap yourself.
Alexander L says, all this debate, we have been to effing space.
Wait, low Earth orbit, charged,
What about
ionized,
what about
plasma,
geostationary?
fluid.
Hold on. What about geostationary satellites?
Geostationary, geocentric. They use electropropulsion.
But they don't. They don't use electroproportion. They actually use delta V.
What about the solar probe and the one that's gone the farthest? What's the name?
Voyager
the Parker?
1 and 2?
Y'all believe in all that stuff? You could believe in that stuff, but
Denialism is a religion.
I don't deny nothing.
That's what
if
you
you
just
could show
did.
me some empirical evidence that that machine is where you say it is, then I will accept that any day.
No, you won't. You'll
What you could do?
It
What you
flex
could
your
do?
religion.
What you could do? No. What you could do is in my messenger, you could send me exactly that. You could show me the proof. If it's just an article saying that it's there without the proof, believe what you want. But if you could actually show me proof that these things are where they say, I'll accept it without. I will accept without even a.
Got it. So would
the ISS work for you? Because we have a friend, astronomy. A Satelloon, okay, because we have a friend, well, we actually have two friends, Astronomy Live and Red Rhetoric, who have both verified and measured the size, position, and photographed the ISS.
Yeah, it exists.
Right, but you say Satelloon. A Satelloon couldn't have that speed.
I'm saying that, right. I'm saying the ISS isn't traveling at the speed that they're saying, and it's not necessarily the height that they're saying. But I'm saying it exists.
Angel, that's the point. They measured the speed, the size, and they photographed the ISS in its transit.
Show me that, because I know the size of the ISS and I know the size of an airplane, and I know how high airplanes fly. So I would love to see those measurements.
Sure.
I would love to see that. I would love to see that.
Takes 1 second. Hold on.
No, just
stop repeating yourself. I'm retrieving the link. It will get it takes me just a second. The page is loading, just that. I have everything ready. So here we go. In the chat, that one is from Astronomy Live, and I will share it to the audience too. There. And we also have Reds. And I'm reading that link right now.
I'll watch the video.
And here you have all of Reds has a bunch
the
of those.
telescopic
So
footage of the ISS.
I'll give you there. You have more than one.
Yeah.
So yeah.
Okay.
So yeah, they measured.
Sorry, I butted in.
Yeah,
I forgot
okay.
to name them all.
they measured the height of it and the speed of it using geometry and parallax.
Okay.
So there's not yet been anybody that has addressed that with they haven't done the analysis. They haven't looked at it, said, oh, here's the mistake.
I don't see numbers on this first video you sent. So hold on, let me see what else you sent. What else you sent here?
And if you're skeptical, Astronomy Live has an open invitation to control his telescope. You can talk to him on Twitter, schedule it with him, and he will help you.
Which one was where they measured? What's the name of the one where they measured the ISS?
I don't see anything where he's measuring it, because I know the ISS is.
Oh, there it is.
I think roughly the size of a football field, I believe, right?
Yes. Yep.
Right.
Okay. So, I'll bring up on screen the one that has the actual measurement in it. Oh
man, my phone might die, guys. I hope. Put down the charger.
We have a follow-up from Who Done It. Tagged me just a few moments ago.
Okay, just a second. I'll spin through this real quick here.
Yes, sure.
This is a 16-minute video. Are you seeing this, Angel?
No.
Oh, you're all right. Well, I'm sharing it too, but anyway.
No, I'm looking.
In the description, they have the details, more details of the measurement, and I think, let's see, maybe the one from Astronomy Live has the actual like a spreadsheet of the calculations. So one of these does have the calculations, so you can go through it if you think it's wrong.
Okay. All right. Well, I'll take time to look through those numbers. And as far as the ISS, I know it exists. As far as the speed, I don't necessarily believe it. Maybe your numbers are going to change my mind. That's fine. Like, facts are facts. I know they run off fictitious forces as well. You have to incorporate that into orbital mechanics. So I know that it'll work in the geocentric model because you use the geocentric forces that Isaac Newton considered fictitious only because he had space as absolute. So, I mean, I don't think it's going to prove necessarily heliocentrism, all of these facts that you're going to send me about this ISS, but I do appreciate
what they do is they falsify geocentrism because geocentrism has very specific things that would have to happen if the Earth is not moving. Then things like the orbits then are different. Gravity's, has to still exist. You don't reject that mass attracts mass, right?
I do. Actually, science does.
Science does not.
Yeah. Static electricity. Static electricity. Electrostatics. You could just lift dirt off the ground with electrostatics off the mass of the Earth. Actually, mass doesn't attract mass. That's why Einstein made bending of space-time.
Like I said initially, within our reference frame, according to Einstein, within our reference frame.
Right. Scientists say gravity can exist without mass, published in the Royal Astronomical Society.
Okay, and
so
no
actually,
citation.
we don't know what gravity is because it could exist without mass, apparently.
No, it can't.
Well, you're gonna have to take it up with them.
Once again, I think the problem is your misunderstanding. But anyway, if you have something to say about electromagnetism or electrostatics, then I'd be happy to cover it. This is the book that I used when I was at university covering electrical engineering. So here's the chapter on electrostatics. We can talk about Coulomb's law, and then we can apply Gauss's law to electrostatic fields. Right? If you want, we can do that. But I don't think it's going to work out well for you because things that are neutrally charged would have no force applied to them. Things that have a positive charge and things that have a negative charge would be accelerated in opposite directions. That's not what we experience. But you're talking not mass. You're rejecting mass attracting mass. So
exactly, because you could just use that static electricity to pick up dust particles from the Earth. You're taking the dust particles from the mass of the Earth.
It seems that you don't understand that objects can experience multiple forces simultaneously.
Right, but we're talking about a force that holds the oceans to the Earth. We're not talking about a weak force. Even though you were trying to portray it as a weak force, it can't be both. It can't be both.
It certainly can. What you do is you take the mass of...
That's Petitio Principi. That's just Petitio Principi. That's putting the carriage before the horse. You're just saying whatever just to fit the model. Switching between special relativity and general relativity when it fits your description of what you believe.
Are you just spouting what somebody else said without really quite understanding it?
No, I'm just saying.
I don't think you quite understood what we said. I think that sounded like you were just parroting somebody else.
I'm saying that you could look at there's plenty of videos where people do static electricity. All you do is static, you pick something up with whatever, your hand.
It doesn't refute gravity because all that you've done is identify that there are multiple forces that apply to an object simultaneously. No surprise at all. If you want, we can draw a free body diagram and we can put together all the different forces that are at play.
Okay, so show me a bend in space-time then. How about that?
So that would be the seminal experiment of that was Eddington 1919, and it's been confirmed many times since then, where the path that the light took near the sun was bent.
Oh man, I even got. Hold on, where is that? Hold on. That's funny. I like that one. That was a good one.
You're not aware of,
fact,
of
but
that?
it's a fact, but it's a misinterpretation. It's a misinterpretation.
It is. Oh,
Even Paul Hill. What is it? Paul Hill. What did he say? If Einstein says space is flat and can be bent, there is no different than saying vibration. Whether it's space or substances in the space. Whether we call it ether or space doesn't matter. Meaning that everything vibrates at a frequency. And scientists already proved in 2003 that not only sound waves travel through space, but there's science that sound travels through vacuums. And you
the
can
hell
look
are you
that
talking
up.
about?
You know what? Everyone look that up. I don't even have to say much. They already proved that. So you're gonna have to prove that that's not the vibrational waves of the damn planets and the sun vibrating. Like what?
Wait,
They found sound out of a black hole. They found sound out of a black hole in 2003.
Hold on, my good sir, because this is the area of expertise of mine. I'm expert in two things: the English language and sound. So, are you referencing the listening to a star thing?
No. 2003. Scientists find sound waves coming out of a black hole. They discovered that sound travels through space. And I could pull up other experiments where sound travels through a vacuum.
Let's just start with the one. Start with the one.
Anyway, so
okay. Hold on. Yes. So the way this works, I don't know if you've seen that what we do is when we make a claim, we give a citation.
Hold on.
So
hold on.
That would be greatly appreciated.
No problem. Sorry about that. You're right.
In the cases where they listen to the black hole or listen to the star, what they do is they take the electromagnetic radiation, which does propagate through the vacuum, and they apply a translation to turn it into sound. The same way, for example, that you can take electrical impulses that travel between trees and plants, for example, and turn them into sound. But it's a translation. It doesn't mean that you're actually hearing the black hole or the star. Okay, it requires a translation.
I sent it.
Okay, we got a first law happening here. There we go.
I know I'm controversial, man. I'm just a layman, guys. Don't just look up the information for yourself. Don't listen to me. Just everything that was stated in this video from his side, from my side, every little bit of information. Do your due diligence, and don't ever believe anybody what they say. Just figure it out. If something's a fact, it's a fact. It wouldn't need a belief. It wouldn't require a belief.
All right. What you should probably try to do is not find pop science low quality summaries of summaries of summaries, because that's what this looks like it is here. Oh. It doesn't have anything that we can look at as a measurement here. There's nothing. He's like one example noted by Gizmodo of a black hole which emanates the lowest note scientists know about so far. It's about 57 octaves below middle C and well below our hearing range, about 1 billion times deeper than the sounds we can hear. You'd expect to be able to measure about one oscillation every 10 million years in a black hole sound, whereas our ears stop hearing sounds short that oscillate 20 times per second. But it says, remember, you would expect to be able to measure. It doesn't say we did measure.
There's experiments where people produce sound waves in vacuums. Like,
But then
you
why
don't
didn't
need
you
just
cite that?
article.
Why did you cite this one then? This one that
I cited
contradicts,
that was
doesn't
the second thing
support,
I said.
but it doesn't support your claim.
It
Right?
doesn't support my claim.
It's not supporting your claim. This is a first law confirmation right here. That's what we're seeing.
If you would like to give the second citation for the sound in a vacuum thing, then yes. But
Anyway,
I
space
think
is
I
in a
already
vacuum
know.
anyway, but that's fine. We're gonna do it like this, just so, because this is what y'all believe, so I gotta do it that way. I'm gonna go with y'all beliefs. Like when you're debating a Christian, you gotta quote the Bible. So hold on. Since y'all believe space is a vacuum, even though we know it's 99% plasma, let's go with that.
What? Oh, now you're
Holy
making
cow.
another claim.
You mean the interstellar medium is a claim?
We don't
Okay.
claim
Yes.
we don't claim perfect vacuum. We claim, yep, there is plasma in space. There are
Yeah.
molecules out there. That's our claim.
Yeah,
Yeah.
yeah, yeah. Not this vacuum. Not that. It's just no air. Which obviously
Well,
that's the definition of a vacuum, but it's not
Very,
perfect. And
very
I get
little
it.
air. There might be
Very
a couple
little bit.
oxygen molecules or nitrogen molecules kicking around.
Who knows? I don't know.
Oh.
Oh, you gave up? Okay.
Was it? Let me ask you. Let's try to detective this one. Was it on a vacuum chamber on Earth?
What?
What you said about sound and in the vacuum.
I presented an article of
Oh, there it is. Sorry.
explaining
Yes.
how,
Okay.
right, yeah, you see. Yeah, sorry, I sent it.
Okay. Physicists
Sorry, I
demonstrate
thought
how
you hadn't
sound can
found
be
it.
transmitted through vacuum. Now, did you just stop reading at that point then?
Huh?
Did you stop reading at that point that I just read?
What point?
Physicists demonstrate how sound can be transmitted through vacuum. Is that how far you read, or did you read more?
No.
Oh. Third paragraph.
The
Yeah.
The requirement is that the size of the gap is smaller than the wavelength of the sound wave. This effect works not only in the audio range frequencies, hertz and kilohertz, but also in ultrasound, megahertz, and hypersound, gigahertz, as long as the vacuum gap is made smaller as the frequencies increase.
Right, and they talk about perfect vacuum. They're not talking about with plasma and all the other stuff that's in the universe. So now,
This
yeah,
is
do you
not
believe that
talking,
perfect vacuum?
Angel. This is not talking about the universe. It's talking about a
geez.
microscopic.
It's the second.
Exactly.
It's the second paragraph here. I'll read it.
Exactly.
In a recent article
Sure.
published in the Communications Physics, they show that in some cases a sound wave can jump or tunnel fully across a vacuum gap between two solids if the materials in question are piezoelectric. In such materials, vibrations, sound waves, produce an electrical response as well. And since an electric field can exist in a vacuum, it can transmit the sound waves, but it's not actually sound waves. It's a piezoelectric effect. It's electricity
Sound and light
traveling.
are the same thing. I mean, sound produces light. It's just a
No,
wave.
no.
Dear.
Sound and light are like the same thing. Not
No, they're
exactly.
No,
but
they're
No.
not. No, they're
Like-
nowhere different. Look,
Angel,
I-
come on.
please, like
They're
I'm
both
a music.
disturbances of a medium. I know you think light doesn't have a medium, but that was proven by the greatest minds in field theory that are way smarter than us, from Eric Dollard to Tesla to freaking Oliver Heaviside to Steinmetz to Maxwell. All these
Dude,
people all
dude. Oh
my
proved this
gosh.
stuff. So,
Dude, I have a show in which who I think is the originator of this sound is electromagnetic nonsense.
Yeah.
Whitson.
not exactly.
No, that
Yes.
wasn't Whitsitt.
Sound is light.
It was long before
It's
him.
kind of
Sound is
similar.
not light. Sound is a compression
I
of the
think
air.
the sound is exactly like. I know y'all just gonna word fuck me. That's fine. That's fine.
I You just literally said sound is light.
Oh, I didn't know about someone saying
Similar.
it before. The first time I ever heard that was with you.
Tesla.
Yeah.
And I actually managed.
They like to say sonoluminescence, but sonoluminescence, while it's not fully understood, it's not sound and light equaling things. It's that
With
sound
get-
can
produces
cause. Can cause. Yeah, it's a
When
reaction.
I said
Yeah,
that.
but it's a very
Right.
specific thing. You need a very specific setup. It doesn't happen everywhere.
They're not equivalent. It's one thing causing another. It's like
Yeah.
a car crash causing a fire. You can't say that cars are equal to fire.
I didn't say they're the same exact thing. I'm just saying that a light wave and a sound wave are just
Hold on a second.
perturbations in the medium. That's
everybody-
their characteristics that make them similar. That's why I said they're light.
Yeah. Sure. Newsflash here. Lisa poops rainbows. Just so you know, I want everybody to know that. Thank you, Lisa. Let me see if there's any other questions for him. PhD Tony says Foucault's mechanical gyroscope, Compton's generator, the accuracy of gyroscopic compasses, the results from GPS and VLBI all demonstrate Earth's rotation.
Brian Cox. And GPS satellite does not prove Earth's rotation. Even Ken Wheeler's smart enough to explain that.
Ken
but
Wheeler is
okay.
a massive idiot.
He
Ken
is,
Wheeler
and he's
is
smart enough to explain
dumb
that.
as
That's what I'm saying.
dumb as dirt.
That's exactly what I'm saying.
So
So,
nothing that he
related
says has
to-
any value.
Related to this question, Whodunit sent a follow-up to the question he asked originally, and he said that all the experts that you're referencing, for example, Brian Cox, who you referenced just now, would disagree with you on geocentrism. Why
I
is
don't care
that,
about
do you
people's
think?
beliefs. I don't care about people's beliefs because everyone's so focused and fascinated on what people believe that they don't focus in on facts. So it's hard having these conversations because people are
When-
mixing in
Angel.
interpretations of data, people's beliefs, and then the facts.
When you
I'm done. Go
quote
ahead,
when
I'm
you
sorry.
quote somebody, you are asserting that their belief is assisting your position. That's what you're
No.
asserting when you quote
No.
somebody instead
No.
of referencing an experiment or some actual evidence.
No.
And
No.
in my opinion, that also
I'm-
creates a problem, which is called cherry picking.
Yeah.
Because you have to take the quote that you're latching onto, but you're discarding everything else that person has to say.
A
So
belief?
how do
Why
you?
is what part of the scientific method is beliefs? And then we'll further that discussion.
But we're not talking
didn't
about
play that,
beliefs. Like
Yes, we are. Because
Brian,
what he's saying is
hold on.
no, hold on. No,
Hold
let me
on.
explain. Let me explain myself, please. I'm sorry. I don't like cutting people off. But just let me explain.
Dude, you don't need to explain yourself. We go through this a lot. Like we already know. So
Right.
when Brian Cox is talking about what you say, he's following the scientific method. But when he says that the Earth is the third planet orbiting the sun, he's also following the scientific method. It's not
He's going
just
by
a
belief.
belief. No. It went like
So when he's saying no experiment proves a motion, he's speaking a fact. Maybe in the future, or maybe you providing these experiments, maybe I'll gain better clarity. But as far as I know, there's no experiments, right? And that's what he's saying.
It's cherry picking.
And then he's saying though that he believes that the Earth's spin. Same thing Einstein said. He's saying the same thing.
Just cherry picking. That's what you're doing.
That's you could call it that, but that's out of his own mouth. So
It's cherry picking. It's contradicting his actual position.
wow.
And also, Brian Cox wasn't saying that. He was saying that Einstein said that 100 years ago. So
I
it's
have
even
two different
worse
videos.
than,
Two different
even
videos.
worse than cherry
I have two different
picking.
videos. I have two different videos. So you're gonna have to, whichever one you're claiming is that, you're gonna have to prove that for the other one.
Yes, I've seen the videos. You just have to look at the
So they're
whole
both-
video.
So
know.
they're both saying about Einstein. They're not talking about his own.
Yes,
So
yes, exactly.
when he says gyroscopes don't prove it today either, he was talking about Einstein too. Or it was just
Gyroscopes? Gyroscopes. I've never heard that one. Gyroscopes.
he said it out of his mouth. So you didn't watch both videos then.
PhD Tony just said that gyroscopes actually prove the motion of the Earth, and we
How about
believe.
the Brian Cox?
I mean, PhD Tony could beat up Brian Cox in a fight.
Yeah,
so
no
I
kidding.
side with PhD Tony.
Yeah. Have you seen PhD Tony?
Hell yeah.
He'd crush Brian Cox. The little twig.
Oh goodness. Oh goodness.
Okay, Bob says this super chat intentionally left blank. Okay, and then Icy Spin says, speaking of plasma, the moon. Am I right?
Hell yes.
Yeah,
They
because
actually proved
that
in
one
the
scientist.
laboratory, they recreated the moon's craters using plasma. So
No.
I just thought that was interesting.
That's ridiculous.
Citation.
Absolutely ridiculous. The evidence
Citation.
hurts says, where does MCToon find these loons? I'm with Toon. Facebook. Facebook is full of there's a sadly and nearly endless supply. Melodic Lyrics says, Brian Cox also says the Earth not in the center. So which
Oh my
cherry,
God, people
which
just
pick are
love
you going to
when people
cherry?
I'm going with the facts of his statement, which the only fact he said was no experiment proves the motion. When you want to dip into his
So you
religious
cherry
belief and y'all
cherry
wanna just
pick.
believe that
You
too,
cherry
go
pick
ahead.
that
I mean,
because it matches your religious
what do you mean
belief.
cherry pick? What do you mean cherry pick? That means, oh my God, okay, trust and belief. Are y'all scientific? Okay,
That's what you're
your
doing.
barometer you're gauging.
That's what you're
all right.
doing.
Just show me what step of the scientific method belief and trust are on. And
No, yeah,
I'll go with you,
that's what you're doing. So
Okay.
you have started
not.
with your
That's what
you have
you're
started with your conclusion,
He said out his mouth.
and then you are picking the things that Brian Cox said and saying, oh, look at that supports my conclusion. Never mind the context, and I'm going to take that, and I'm going to make that be the thing that I declare is the fact, and I'm going to ignore the other things that he says that completely contradict that when in context. So we've seen it. Kango44 says, Angel, do you think you might need an education in a subject to understand information from subject matter experts?
I'm sorry, I was looking for what you were saying.
Do
can you
you
repeat that? Okay.
Do you think you might need an education in a subject to understand information from subject matter experts?
Education is important and it helps a lot, yes. But you could also be knowledgeable and you could learn things. You don't have to just take things for face value, especially when you have scientists making a food pyramid saying that Lucky Charms are better for you than steak and chicken, okay? You could be a person who makes their own choices, all right? And the Invention Secrecy Act of 1951 exists, whether you want to acknowledge it or not.
Well, you are all over the
there's
place.
science behind technology, and there's mathematics behind technology. Whether you want to admit it or not, that's fine.
Of course
But
we
there's certain
of course we
sciences
admit
we're
that.
not privileged to. We're working off information that's all we have. We don't have the whole pie yet. And we're here debating off these little pieces that we know. And you want to sit as the expert because you agree with the extras, which is cool. That's fine. But not everything is a fact. And we're allowed to look at these alternative views of data. Whether you agree with it or not is fine. Agreement has no bearing in science. Belief has no bearing in science.
We're not
Trust
claiming
has
that.
no bearing in science.
Yeah, we're not claiming any of that.
Position,
Why
yes,
are you putting
You're
that
telling me
on
what
us?
Brian Cox believes and using that as proof. So
That's what you are doing. You are the one doing it
How?
literally, not me.
How?
I'm saying let's
How?
look at evidence, and you're saying, oh, look at this quote from Brian Cox.
So why is he saying there's no
let's not
experiment
look. Let's
that
not
proves
look
the
at
Earth's
us.
motion?
Let's not look at a quote from Brian Cox. Let's not have
Why did
religious
he
belief
say-
in a cherry
why did
pick
he say
quote
there's
from
no
Brian Cox.
experiment that proves Earth's motion? Why did he say a gyroscope don't prove motion?
I would say it's mostly because you probably didn't understand what he was saying in context.
I didn't understand. Oh, so now my ears don't work and I can't hear
Yes,
him
that's
right. All
correct,
right, that's
yes.
good. If that's how your assumption science works, keep it, bro. What the heck?
You would need
weird.
evidence. That's what you're missing.
Show me
Icy
the
Spin
evidence.
says
If he's saying
diet.
there is none. So that means you're interpreting the data wrong, which is fine. You can have your belief.
in all
But
of
the
these-
fact that there's multiple
Angel,
alternatives.
you should have a little self-reflection here. All of the things that you've cited don't actually have behind them any experiments supporting your claim. Everything that you've sent in the chat here, every
experiment
single
proves the
thing,
Earth don't move.
you
I don't
did
understand what
not have any evidence in them. You had one, and you had things that contradicted you. The most recent one, you said sound goes through through vacuum, but it doesn't.
Yeah.
It's electrical. It's electricity that goes through a vacuum is what your own citation said. It contradicts your claim. That's the first law.
No, it said sound goes through it. It turns into electricity. So how is that going against what
Because
I'm saying? And then
I'll
saying
read it
space
again.
isn't a full vacuum. So I'm saying the sound could travel in a
in
vacuum.
such
it returns
materials,
electricity.
vibrations produce an electrical response as well. And since an electric field can exist in a vacuum, it can transmit the sound waves as the electrical field. So it's just the electrical
And
field that's going
space
through the
isn't
vacuum.
a full vacuum, right?
Space is a stronger
there's
vacuum than
gases,
this experiment was.
Right. There's gases, right?
Not near enough to transmit sound. They're not close
Go
enough
look
to
up
each
the
other.
interstellar medium, because I beg to differ. Look up the Oort cloud. Look up the heliosphere. If we're talking about our own solar system alone,
None of them have
cosmic
enough
jets and
density.
all the crazy. No, man.
None of
All
them
right.
have the density to
That's fine.
transmit sound.
Right.
The-
I know,
the-
because you think
the
the
gas
star
particle.
is 100 light years away, which is how many trillions of miles you think we could see it? Because it's
Of
all right.
course,
You know
of
what?
course
Your
they
beliefs
are.
are so crazy that you think based off craziness, and then when someone says something, you already have these preconceived notions.
Based on what
and it
craziness?
doesn't make sense in your mind because you have all these preconceived notions. So it's hard to have a conversation in that way.
What craziness are you talking about?
The fact that you think you could see a star that's 1 trillion miles away is absolutely madness.
Why not? What's wrong with it?
Why? Why can't you see? How could you see 1 million miles away, 1 trillion miles away?
All you said was it's madness. So I'm wondering if you have something other than that.
Yeah, there's something
so
called
far,
line of sight.
you've got
you can't see.
Personal incredulity
Like there's
so far.
vanishing points, right, where you can't see. There's something called inverse square laws, right?
Okay,
with
cool.
the light.
Let's
And you're talking about traveling, right?
let's go through the inverse square law. I'll tell you what. I will put it up on the screen. I'll put up the camera here, and I will be your hand. You tell me what to write. How do we apply the inverse square law? All right, here we go.
Inverse square law. I'm not a mathematician. I'm going to explain the inverse square law. The inverse square law says as light travels, the farther it gets, the distribution is going to get smaller. All right. So when we're saying that stars are trillions of miles away, we're saying these things are super massive and super bright. In order for you to compensate for these equations that you're about to write.
I'm not writing anything unless you say it.
Mhm.
Okay, so let's go. All right, so they're trillions of miles away. Okay, now what?
Now what?
We're going to go through the inverse square law as you have cited here, and as Max mentioned earlier, you make a claim, you bring forth the evidence. So we've got.
Oh, really?
All right, so we've got the inverse square law. We're going to apply it to stars that are trillions of miles away. What do we do?
That's every star.
What's the next step here that we do? How did you do
Name
that
a
to
star.
quantify it?
Go ahead, pick a star.
Let's go with Sirius. That's a good one. All right, here you go. How far, Eric Burns? Eric Burns, how far is Sirius away from us in meters? Please, can you do that? Eric Burns is an astronomer. He's also a teacher, and he's in the live chat, so he's helping us here. He's looking it up. Okay, so what are we gonna do once we get the distance? Okay, we'll have that in a second here. It's going to be some number of meters. Now what? What do we do next?
How about you prove to me that star is that distance? The star
Okay,
there.
no, but this is your chance. You said inverse square law.
My chance for what?
This is your chance to support your claim. You said inverse square law, and you had some incredulity about how the inverse square law worked.
That wasn't the only thing I said. You focusing on one thing now.
Yeah,
what's that about?
we can only do
What's
one
that
thing at a
about?
time. We can what it's about is you can only address one piece of evidence at a time or one claim at a time. Okay, Eric Burns has it. All right, we've got 8.1457 times 10 to the 16. All right, there we go.
Prove that number.
Okay, so no,
Prove that number.
this is your claim that the inverse square
Prove that
law.
number.
Sorry, let's go back to this is your claim. You said the inverse square law is somehow ridiculous or crazy, and because of stars that are trillions of miles away. Okay, so now we're going to apply the inverse square law.
I said the inverse square law is crazy because stars are trillions of miles away.
Yeah, that was your Max. Is that what you got from him? Oh, Max isn't there. In the chat, is that
Is word fucking all you have?
Is what?
Honestly, is like word fucking all you have? Like I don't have a better word.
Well then maybe restate your claim so that I'm not confused by it.
You're assuming the distance to the star.
No. Your claim was something about the inverse square law. So can you restate your inverse square law claim?
Your distances are impossible, and I'm saying you can't even prove your distance.
Quote. Yeah. Your distances
to stars
are impossible. Okay.
Right.
Okay. And then how does that relate to the inverse square law? Is there more to the sentence? Yeah, is something like your distances are impossible because of, or something like that? I don't know. I don't want to put words in your mouth. What's
I'm trying to figure you out right now, sir, to be honest.
So what's what I'm trying to do here is to get your very specific claim about the inverse square law with the distances. So what is your claim?
I don't have a claim. Y'all claim these stars are this distance away.
No, you did. We've got the beginning of your claim here. Your distances are impossible, and then something about inverse square law. So what's next? What's next? Because of the inverse square law?
Proving the distance that you're saying these things are.
Because just complete your sentence here, your claim here, right? Your distances are impossible because of the inverse square law. Is that what you're saying?
Why?
I don't want to write down anything that's not your actual intention.
Don't write nothing down. Write down how you found that distance to Sirius.
Okay, you're changing the topic. You're changing the topic. I want to stick to this topic first.
Because you're going to try and quote me on the inverse square law.
Yes, I 100% am trying. Yeah, so absolutely. You've completely.
If that number don't exist.
You figured out what I'm trying to do. I'm trying to have you make your claim and then have your claim be tested. Right, we're going to test your claim. So you made a claim about distances.
Show me how you got the distance to that star. I'm testing your claim.
You've changed around your claim here, and you're trying to change the. Oh, I've got a card for that here. Hold on a second here. We've got just a second. I think I have it in here. There it is. That's the burden of proof fallacy here. So saying that the burden of proof is not with the person making the claim, that's you. But instead with someone else to prove. So you've made a claim about the inverse square law. Luminosity.
Distance is based off luminosity. So basically, according to science, the way they got these distances was saying that the sun is closer to me than my car because the sun is brighter than my headlights.
Okay, so
now we're going to say stars are trillions of miles away with zero proof. Okay. And now we're about to try and have an honest discussion about quoting the inverse square law.
I'm trying to have an honest discussion. So here, your distances are impossible, and then something I want to make sure I understand your claim because the audience has said
are impossible because distances are judged by luminosity, which is like saying the sun is closer to me than my car because the sun is brighter than my headlights. And your whole
hold on, your distances are impossible because distance
is judged by brightness or luminosity, which is an assumption.
What's an assumption though? The luminosity?
Yes.
Luminosity is measured.
The assumption is saying something is closer or farther because it's brighter or dimmer.
That's not. So you think that's not correct? Okay. So your distances are impossible because distance is judged by luminosity. Is there more that you want to do about inverse square? Is this good? I mean, because inverse square and luminosity are related. Yeah. Is that good? Okay. So your
Whatever,
distance,
whatever
yeah.
you're gonna try and do to finagle this situation,
Okay.
try it, brother. I mean,
So now, yeah, the inverse square law is well known. You're absolutely correct that it is a law, and it's something that astronomers use to determine distances of stars. Okay, so now when people say, and I've heard flat earthers say this a lot, that they make claims about inverse square law in stars, and then I do the same thing. I say, well, let's go through the math, and they do the same thing. They refuse to do the math. So the people that are not scared to do the math would be astronomers. In fact, they rely on the math. It's part of the measurement. So, for example, if something is farther away, it's not as bright.
On a paper, what does it do? It's just numbers. Like what?
Well,
how are you getting that distance? That's the point.
Yeah. It's a great question. Yeah, there's no conclusion to that. Eric Burns, can you
I think we have the answer already. For prove the distance to Sirius, that would be that it has a parallax angle of 0.37921 arc seconds.
Okay.
It moves. So now I know how far it is because it moves. And it's bright.
So there's the distance.
That's it.
The distance is based on the parallax angle for Sirius. Okay. And hold
on. Okay. So let's say I was gonna build a wall. All right. And let's say I was a 16th off. Now let's say that wall is 1 trillion miles now. How off do you think I would be?
It doesn't matter. Okay, so we've got right here, we've got this. Yeah, that's not applicable here because we've got this distance here is 300 million kilometers. Right? And so let's say that the blue shift, this yellow line here is the light from Sirius.
Blue shift is distances again.
Okay. No, I'm just saying that this, because I'm reusing this diagram here. So we're going to say that the yellow line here is the light from Sirius on both of these, and so there's this 300 million kilometer gap between the Earth, the observation on both sides, and in relation to the farther away stars, Sirius shifts by that 0.3 arc seconds. Okay. Now this is using devices that are accurate to wrong page. You'll notice how many significant figures are reported here. 1, 2, 3, 4, 5. 5 significant figures. So they're not doing 5 significant figures just by guessing. Right. These 5 significant figures are used because this is how precise the measurement actually is. So when you're like, oh, if they do a wall this and it's off by this at 1 million miles, what about this? This is the addressing of that. Okay. This is 5 significant figures in the measurement of the parallax of Sirius.
They're measuring the parallax based off the horizon and none of this is.
They're not measuring. Hold on a second. Do you not know? You don't know how they measure parallax? There's no horizon involved.
They judge the distances based off other distances that they already know, which they don't even know. They guessed them. So
none of these are guesses.
There's no baseline distance for them to guess these distances.
None of these are guesses.
You're just saying that because hold on. I'm sorry. You're just saying because this star in this position, right, has this parallax, right? During these times, you're saying you could judge the distance based off these minor changes?
Yes, 100%.
You don't even know how far it is, how big it is. You don't know none of that.
This is how. Well, there's no guessing. This is a measurement of how far it is, and how big it is doesn't matter. It's not applicable in this situation. So yes, absolutely, since they are able to measure precisely to 5 digits. But your refutation of it seems a little skewed because you thought that somehow the horizon was involved in this. So I don't think you quite have the subject understood well enough to actually have a conversation. And so this is an instance of not tall enough to ride the ride.
No, that's fair. You could try and portray that. You could try and portray that, but at the end of the day, you can't show me how they're gonna get a distance to a star. And maybe if you can, you could send it.
Oh,
But
well, here.
there's no way.
I'll show you.
So writing on a math paper,
show you
there's
right
no
here.
way on
Here's
that
how.
paper you could show me where the star is. You could try and triangulate
here's
that
how.
system all you want.
It's not
You
triangulation.
can't do that because then you triangulate the moon being close.
Hold on.
You can triangulate the sun being close, and that math wouldn't even go for
Hold
your
on.
model. So now we're picking and choosing, if you ask me.
Toon,
If you want to do
Eric,
trigonometry,
hold
Okay,
on.
I got it, Max.
Hold on.
I got it. I'll pull it up.
Oh, okay, perfect. Yeah.
Mhm.
So we just got from our friend, astronomer, a diagram of parallax with the equation.
Awesome.
Just-
Wait, is it in chat right now?
I'm bringing it up.
Yeah, no, he's in the YouTube side chat.
Oh, damn.
All right.
Okay. Maybe I could check that out later. That'd be pretty cool. to see that.
Toon will pull it up. Give it just a moment.
Okay. Thank you. Thank you guys for being so patient with me. Oh my God, I know I'm a fucking handful. I got it.
All right. Well, we've had worse.
Man.
All right. So
Yeah.
here is a not to scale diagram, but it's similar to what I showed. You've got the Earth on both sides of
Right.
the sun there.
I mean, it's
6
nice
months apart.
math, but
Okay.
that's
Hold
all
on, hold on.
assumption-based
D-
stuff, though.
No,
But I
none
get
of
it.
this
I get
is
it.
none of these are assumptions.
Yes, it
Exactly
is.
zero
The
assumptions.
assumption that the Earth moves, the assumption that's not even elliptical. It kind of just says elliptical. That's all assumptions, man. Like
None of these are
these
assumptions. None of these are assumptions.
I see. So y'all base your science on assumptions and then think you could triangulate.
These are
the
not
position with your
assumptions.
math.
You
That's
just
cool.
repeating
That's
that they're
an
assumptions
That's an
doesn't convert them from
assumption.
measurements to assumptions.
That's an assumption. You
What part of the scientific method is deny things that people have done? None.
denying
That's not
nothing.
part of
I've
it.
never seen no proof of the Earth rotating, so now I'm seeing a diagram that's strictly based on the Earth's rotation. And
This
it's
is
like,
not
how is
based
this
on the Earth's
factual?
rotation.
Well,
This
we
is
don't have no experiment
Is
to prove
English your first language? Angel?
it. Have you ever been to the Bronx? Like,
English. Is it your first
have
language?
you ever been to the Bronx?
I don't care. Is English your first language? Because Max's first language is not English, correct, Max?
Correct.
Okay, so Max, do you know the difference between rotation and orbit?
Yes, sir.
Okay, now your second language is English, and you know
Yes.
the difference. Angel's first language is English, and he doesn't know the difference between rotation and orbit because he's
This dude
swapping
just
in
disrespectful
swapping in
to get views
rotation
and
when
stuff,
this is
and
a
it's like
diagram.
fucking-
This is a
just
diagram
because
of
someone
orbit.
says the wrong word, now he wants to make him look stupid. Like, bro,
I'm
is disrespect all you
attempting
have?
to.
Like,
I've
you're not
tried to
attempting
attempt
do
to
shit, but, like, be
correct you on that.
disrespectful, and it's like I don't understand because you're just getting passive aggressive a little bit. Now I don't understand. Like I don't understand.
I've
But
multiple
it's fine.
times
Like, if
tried to
that's how you win
clarify.
debates is being disrespectful. That's
Angel.
cool. Like,
Multiple
That's cool.
times I've tried to
But-
clarify. Okay.
bro,
And-
I don't
and you
care at
double
this
down
point.
on the
Just
wrong
check
term.
the disrespect at this point. That's it. Like I don't
Angel.
know, man. If you want to further this conversation, because it's not gonna go well. Like I don't like that. Like I've tried to be cordial. Maybe I get worked up because I get passionate. But at no point have I disrespected you because I'm a man and I say anything to your face. I would not say anything online. So I don't understand why you would do that. I get it. Maybe you want views and stuff, but I don't have to act a certain way to people. Like I'll always be
Okay.
me at the end of the day.
All right.
So I hope you
Angel,
address
stop
me better
talking.
next
Stop
time,
talking,
please.
Angel. Stop. You
Don't
asked.
tell me when to start
You
talking.
asked.
I know I'm in your house, but
You
don't do that either,
asked.
please.
You
I
asked
can
me.
make you stop talking.
You asked me. I was very kindly giving you FE, free education, after you asked me how we measured the distance to the stars. And I was explaining it, and you didn't let me get one sentence out before you rudely interrupted. I don't care if you're from the Bronx. It's rude to interrupt me when I'm giving you FE, free education. So let me go back to this. And if that hurts you and you need to leave, then leave. I don't care. I'm going to present this. And if you're too rude to accept this free education, then that's on you, not on me. The Earth orbits the sun. The radius of the Earth's orbit is known. It's been measured for centuries. It's not assumptions. It's hard science. Repeatable through different lines of evidence that all agree with each other, even though they come from different methods. The star there would be, in this instance, Sirius. And the angle there in this diagram is lowercase p, the parallax angle. And then you see the background stars. The background stars are so far away that they don't exhibit a measurable parallax by the measurement precision that's allowed. Now remember, 5 digits of precision. This has nothing to do with the horizon. I don't know why I said horizon. These were typically done by the Hipparcos satellite and other satellites that are in orbit around the Earth, so they don't have the air of the atmosphere to interfere with it. So the formula is pretty simple there. The distance in parsecs is 1 over the parallax angle in arc seconds. So it's the inverse of arc seconds, which the arc seconds was 0.37. And I'll put that into my calculator here. All right. Give me a second and we'll have, oh, you're seeing you're seeing this, right?
Yes.
All right. Sometimes I forget which one we're looking at. So our angle is 0.37921, and we're just looking for the reciprocal of that, which is the number of parsecs. So the number of parsecs is, right, and then you can respond after I do this, right? And then a parsec is an actual number of kilometers. 2.6371 parsecs. So there you go. There's the distance in parsecs, rounded to 5 significant figures. Okay, go ahead.
You need to unmute yourself now, Angel.
So did you have a question, or you just wanted me to respond on what you did there?
Well, you asked me how they measure the distance to the stars, and I gave you the method that they did. This is an application of geometry.
Yeah, I see. Yeah, I know when you're doing geometry and trigonometry on things trillions of miles away, right? And then you're using Earth's rotation when it's really the star's rotation, and I guess either way could compensate. So,
Orbit, not rotation.
Orbit rotation. I mean, I'm using the wrong word, but you know what I mean. So, I mean, you could clown it, but
I don't know what you mean, because these are two similar concepts that both apply to the Earth's movement. So when you mingle them, I'm not certain which one you're talking
parallax,
about.
you know you're talking about orbit, right?
Yes, orbit.
All right. So we know we're talking about orbit. So you're just being condescending now because you know you're smart enough to know that, right? So, I mean, you just went on to try and act innocent. But, I mean, come on. We know what we're doing here, man. Come on. I mean, be more genuine than that. Come on, man.
Well, we're used to dealing with flat earthers a lot who make a lot of mistakes. So the distinction is quite important.
Right. That's what I'm saying. And you're going to put a microscope on every little thing like that. I think that's disingenuous.
Yes.
Disingenuous.
That's what you do in science, right? If you're like, oh, I forgot the negative sign in this math. Well, that's a big deal. Oh, I forgot to shift the decimal point when I was dividing by 2 decimal points. Well, that's kind of a big deal.
That don't make me wrong. That just made me use the wrong word. And then we could correct the word and move on.
Yeah.
So I get what you're trying to say. I get the analogy.
Okay, so we don't need to go meta about the word. If I correct you on the word, just say, hey, thanks.
Right.
Right.
Or stop being so condescending about it.
So now, you asked, and if you're like, that's cool, that's good. So, or if you have a response to that, we can have the response or move on. Either way.
I mean, I did, but I mean, if you didn't catch it, it's fine. I mean, it's fine.
Well, I did catch the personal incredulity about it.
Mm-hmm.
But I didn't catch any substantive response. Right. And that's fine. If
you know, we could use the Pythagorean theorem and we'll make a square right now. So like, that's the practical application of that math. I mean, that's just a math problem that's on a paper that you won't be able to prove to me the distance, like beyond this math. So, you can't show me the real world application of this math problem.
I just did.
Like,
that's what I literally just did. Because the parallax angle
and the moon. So then the sun and the moon are 4,000 miles away, right? If we do the trigonometry.
Oh, let's go through that.
If you want that. If that's how we're doing it, then right?
I'd love to go through that.
That's not how it works.
I'd love to see that one. The sun and the moon are.
I don't have that stuff on me. I've seen it.
Oh.
I'll
Oh.
fly by it. It floats around somewhere. I'll get it.
Okay. All
I'll
right.
get it. That's all the flat earther shit and their craziness.
That is exactly what they say, but they actually never have once provided any of the math. They've just made the claims.
I'll show you something, and you can sit there because you're better at math than me, and we'll conversate about it.
I believe you. Yeah.
Yeah.
Right.
You see, and those little disrespects right there, that just know why
I'm just
the
agreeing with
temperature is
you,
the way
man.
it is.
Just
No,
agreeing
I'm
with
just
you.
saying.
All right. Icy Spin says scientists dedicate their lives to Angel. And then Icy Spin says, and orbits don't happen because of gravity, right? So what do you think causes orbit? Like the Jupiter's moons?
What causes orbit?
Yeah, why do Jupiter's moons orbit Jupiter?
I mean, these are questions I ponder myself. I've seen magnetic orbit, I've seen electric orbit, I've seen different things. I don't have answers to these questions. I mean, a lot of these things are just data that's interpreted. Then they have these images. Then they have an artist come and draw these things up. So, I'm not really sure what Jupiter's moons actually look like. I'm not sure how all of that works. Like, I'm not the all-knowing oracle of these things. I have no idea. And I could say that honestly. And I could say no one could prove a bend in space-time. And I'm just saying gravity is an acceleration equation. And I don't believe any of it outside of that. And I don't think they could prove it. And maybe he can. And I'm denying stuff. Maybe I'm denying stuff. I don't know.
You
But
are.
I just haven't seen it.
If you're interested in, for example, watching Jupiter's moons, New York has a public observatory that you can go and you can look through a telescope at Jupiter's moons.
I've
And
actually been there before.
Really? Have you?
I never looked through it, but I've been there before. I know what you're talking about.
Oh, okay. But I mean,
Yeah.
just like, if I have this book, but I never read it, what's the value of that? I would suggest you go to the observatory, or for example, I'm watching here on Google, there's the Bronx Science Astronomy Club. I'm pretty sure they would be more than willing to let you take a couple of peeks at Jupiter's moons through a telescope.
So what you said was, in order to know about the book, I should read it. And I feel like that's been my whole point in this, was just, like to read these scientific papers yourselves, people, and, that's it. Like, I think that was my main point in all of this. And even if I risk looking crazy in public to people, I think it's important that people have their own brains and they try and understand these things so we can push science forward. I feel like there's a real stagnation right now between people's beliefs and what's the actual new evidence coming out as far as what's real or not. Even the James Webb Telescope and the way it's reshaping cosmology, I think we should be open to, questioning things in science without like attacking people. And, I don't think I'm the voice or the person that's gonna, I don't think I'm the person who's going to pioneer any of this stuff at all.
Angel, the point of science is questioning things. That's what scientists do. Icy Spin asked that. Icy Spin asked that question.
But
and this was, I misunderstood his question. He said, scientists dedicate their lives to, and then for you to fill in. Finish that question, that sentence. Scientists dedicate their lives to.
I think studying the secrets of nature.
There you go. That's a good answer. Not stopping a further understanding.
Right.
Yeah. So when somebody comes in,
these scientists share sponsors. There's alternative versions of data for a reason. Is that we could look at this data, but people can interpret it different ways. And I think that's important, that people look at these other ways of viewing things and we really weigh and measure. Like, I think as people, because there's people who get paychecks and they might not necessarily have people's best interests in mind. And they're really incredibly smart people and they take their time to learn these things. They should be respected, but not all scientists agree. And I think, that's something to pay attention to. That's not something to sweep under the rug.
The problem is that you have these fringe scientists And there's certainly some value to them, because occasionally somebody will come from the fringe with some crazy idea that works out to be correct. One example, Einstein, for example, it was a fringe scientist at one point. He came up with an idea that people like, what the hell is that? Turns out he was right. So, all right, melodic lyrics is good news, everybody. The cosmic microwave background radiation has shown Angel's position is worthless. Yay, science.
That was funny.
Flat Earthers attempt to use that as well, which is weird because that confirms the Big Bang, which they don't agree with.
Yeah.
That actually isn't true. Astro
Kate Sathix, who actually works at NASA, says parallax observations show the closest star is more than 4 light years away. If stars are going around the Earth, how can they go faster than light?
That's explained in general relativity. That's why the speed of light doesn't have to be constant in general relativity. That was in special relativity.
What the hell are you talking about? The speed of light is constant.
No, it's not.
Oh
The
my
Michelson
goodness.
Gale-Pearson experiment proved that.
Oh my
the
gosh, you're
light drag.
so wrong. Oh my gosh.
You can
so
go to
wrong.
Charlanov's factual whole analysis on that. You don't have to
Oh my
believe me.
gosh.
Look up
Oh
a
my
scientist analysis of that.
I
There's
have.
plenty of them.
Oh dear, I
There's
have.
plenty of them. There's plenty of them. Don't believe me. Look
I
up the
don't
scientist
believe you.
explanation to this stuff.
In fact, I look
have
at what the
plenty of
scientists have
PDFs
said.
for that. If you want to do ether, I'll drop. Like I said, I want to do that. We could do that sometime with the ether and all of that if you want.
Yeah, this is a good one. Icy Spin says, what plausible experiment would change your mind?
About what?
Any of these things. Motion of the Earth.
Motion of the Earth. How about a positive experiment? You know?
Be
That'd
very
nice.
specific. What would change your mind? What
positive
type
experiment,
what
something
type
that's
of
not-
experiment? All right, you're just like a flat earther. When
I'm
I ask
qualified.
them
I'm not qualified.
what
I'm not qualified to answer that question. It would be too.
this is very important. If you're not qualified to answer that question, you're not qualified to have an opinion on whether or not the existing experiments are good enough.
I'm quoting other scientists' analysis, so this is not my opinion. That's what I'm telling you.
Your opinion
That's all I'm
is
saying.
no.
That's all I've been saying.
This is absolutely your
No,
opinion.
it's not.
Because your opinion
Go to
is
Charlanov.
these other people.
Go show Charlanov's factual analysis of the Michelson Gale-Pearson experiment. Don't take my word for nothing. Just use your eyes and read, everyone.
Oh my gosh. So, all right, we've got from Icy Spin, the answer is none. Otto says, I want my $2. Oh my gosh. Do you have a paper route?
Yo, we're gonna kill some of these people. Oh my goodness. That's funny.
Otto, that is so perfect. I have not seen that movie for so long.
Oh man.
Oh my gosh. What movie am I talking about? Do you know? No, you can't look it up. You can't look it.
I'm not. I'm looking at my phone. It was dying before.
Max,
Sorry.
do you know what movie that is?
No, not really.
It's not Say Anything. Oh my gosh. It's not Say Anything. All right. Kango44 says, did you guys hear they changed the original Alien poster? In space, people can hear you scream. Oh my gosh.
Yeah.
Oh, one of the points in that particular thing is that it said it went above like gigasounds. So above that, the frequency is so high that the space between the waves becomes infinitesimally small, like super small.
Yeah. You
So
can't go
it's
through the
talking
air.
about like really small vacuums.
Man, nobody knows the movie about the $2. Oh, there it is. Chilgamesh got it. Better Off Dead. Is he the first one to get it? You know what, Chilgamesh?
How long you been live for? How long you been live for?
Over 2 hours.
Oh my goodness.
We'll wrap this up here. Icy Spin says, why is the derp always delivered in paragraph form? Zoomer says, what does he think sound is? What is sound?
It's a disturbance of the medium.
Could you be more specific? I mean, sound is very specific.
It is.
Yeah.
Not an emission. It's just a disturbance of the medium and the air molecules or whatever molecule they're vibrating. Like, that's all it is. It's just a disturbance of the medium.
Can you describe the nature of that vibration?
In what way? What kind of description do you want?
Right. The answer is it's a compression. It's not longitudinal, for example. Like waves on the top of water are longitudinal. They move this way, right?
Mm-hmm.
But sound waves move this way, right? They go forward and back. So it's a different type of a wave, different type of disturbance of the medium.
Understood.
Just it's a pressure of variation, not a longitudinal movement variation. Kango 44.
That's what that light is.
Kango 44 says, Angel, is moonlight cold?
I've seen these videos. I don't know, man. I've seen some good debunking ones. I'm literally not gonna touch that at all. Just look up scientists recreate the moon's craters using plasma.
It's nothing to do with the temperature.
The interstellar medium is plasma, and I think it just opens a interesting conversation along with lunar waves.
This is a NIST certified thermometer. Just a 2 weeks ago, about I used that magnifying glass to focus the moonlight on this. It was very slightly warmer. It may have just been an anomaly, a margin of error in the measurement, but it certainly was not.
The moon has a heat signature.
Yes, it does.
You know that?
That's correct. It outputs energy, photons in our energy. Yadawatt says, what is better argument, a quote or an experiment?
Experiment. So there's no experiment that proves Earth's rotation. That was my whole point.
Except there are, and your refutation for it is quotes. Icy Spin says missing the forest for the trees. Rick says, Angel, generally when a scientist expresses disagreement, it's based in knowledge and experience. Even then, they can be either right or wrong.
I believe I've done a great job telling people I don't know. Let's further these discussions. Let's talk about it. I didn't come here as some expert or all-knowing oracle. I did not do that at all. That was not my goal.
Okay. Arnold says, go that way really fast. If something gets in your way, turn.
Great advice.
All right. And we've caught up now.
I wanted to touch a little bit on paradigm shifting, if I may, for just a second. So there's two PhD physicists right now which are challenging our current conceptions of gravity. Those are Claudia de Ram and Yvette Fuentes. And they're developing two different hypotheses for gravity. Claudia de Ram's theory is called massive gravity, in which the graviton is a particle that has mass, and that kind of fixes the problems we've been having with dark matter and dark energy. And Yvette Fuentes, I don't remember her hypothesis off the top of my head, but she is working on something also kind of quite revolutionary. But their starting point, and these are people who are trying to improve our understanding of gravity as we have it today, their starting point is that relativity is true. So even people who do paradigm shifting science today start with working with relativity, which is a very telling thing. And there's a channel, I'll get the link to the audience in just a moment, but you can hear them speak. They give lectures, and they're actually doing the science to verify their hypothesis. But their starting point is that relativity is true, and that is very telling.
I mean, relative motion works for different reference frames, so I mean, it's understandable. Like, you know that. I know I'm not totally against relativity because the way Mach has the universe kind of similar, and I'm not stuck to one model. So since I don't know everything, I just like taking facts from every little bit, every little theory, every little thing. So I mean, relative motion is a science. I'm just saying that the Earth is the fixed point, you know, and I'm sure you presented evidence that disagrees with that. That's fine. I don't necessarily believe you provided the right evidence. I mean, I could be wrong. Like I said, I'm not expert or anything. I haven't seen anything that convinced me personally yet. But you know, I'm open-minded. I don't know everything. So that's why I want to further this discussion, because obviously, since being an engineer, you are somewhat of an expert, right? You are an expert. You know, you deserve your respect on that. That's why I would like to further this discussion. You're obviously a knowing person, and I'm not impossible to deal with, even though I am a little passionate about things. And you have to prove it beyond a reasonable doubt with me. I guess I'm skeptical.
That's not how science works.
That's fine, you know, and personally, I think that's the new definition of science, where, you know, when it came out of Greece and what they built out of it. I don't think in essence, the true essence of science, that's what it is. But that's fine. I understand what they created out of it. But I really think science proves things true. So, you know, that's how I dive into these things.
The thing about science is that there's nothing proven in meat space. Proof is things you get in math and logic. You get proof when you're doing baking with yeast. You get proof when you are measuring alcohol purity. But in science, you don't get proof. The door is always open to some improvement or better understanding.
I mean, I understand what you're saying.
Because if proof existed,
in this conversation in a way.
Let me say, if proof existed in science, then relativity was proven, and every single person that ever said anything against relativity would say, oh no, you don't get that. You don't get to disagree with it because it was proven. But no, nobody says that in science. The door is open. If you want to disprove relativity, go ahead. The bar is high. We're not just going to take a quote. You're going to have an experiment. But if you do disprove relativity, there's an expensive Swedish prize on the way for you.
That would never happen, and I would not be the face of that, because
well, of course you're not.
All the proof, that would never happen.
But people are trying to. The people that did was it Gravity Probe B? No, it wasn't that one. It was the ones that was a frame dragging people. The people that were working on the frame dragging problem or experiment that recently came out, they were hoping that it did not match relativity. That was their hope, because that would then get them that Swedish prize. But in fact, in the end, that frame dragging experiment matched relativity's predictions. They were still excited, but not quite as excited as if they had made a breakthrough. They would have been on the forefront of the new paradigm, right? Here's the book, book by Thomas Kuhn, The Structure of Scientific Revolutions.
Kuhn, very good.
This is what everybody wants to do. They want to be in the next version of this book by whoever's going to write the next one. And so should anybody ever falsify relativity, that book is that's going to be what this is talking about.
Besides for a predictor, I don't think it's ever been proven, but you're going to provide me.
Of course it hasn't. That's the whole point.
Experiment-wise.
That's the whole point. Nothing's been proven in science. We just went through a whole conversation about science doesn't prove.
The motion of Earth. I don't want to say relativity, because
the motion of Earth has never what?
Never been proven.
There we go again with the proving thing.
Right, but
There's-
You
that's
don't
it.
seem to
Then
get this.
So what you're saying? Hold on, I'm sorry. So then what you're saying is we technically that it's just a belief system
No.
no.
based off evidence that you're saying we think
It's-
it works this way because this is the best prediction model we have, right? So
Here's
basically,
the best thing right now. Yeah, that's
Right.
what we have. This is the best thing right
So-
now. If somebody has something better, bring
Right.
forth the better. But right now, this is the pinnacle. And for centuries, the motion of the earth around the sun has been measured in different means, all in agreement with the fact that with earth moving and with the velocity. They're all in agreement with each other. So when you have multiple lines of evidence, that's a even bigger confirmation, and the bar is significantly higher because these two things that aren't related to each other agree at the end. That's huge.
I personally, the way I've seen the evidence, I see that it could also be used on the other side, that the things are spinning around us, and maybe that's because
Right.
not
And
that
we
smart.
we
I
hear
don't know.
that a lot. The problem is for us to accept that the stars spinning around us would have some kind of effect down here in the ground. You need to come up with a mechanism that would cause that. And so far, no one has an answer for that. Why they have the
That's the
claim.
typical force.
Hold on. I'm not done.
Sorry.
They have the claim. We've heard this countless times. The stars are spinning above us, but no one has an answer to the mechanism that would cause the stars spinning above us to have, for example, the effect of Coriolis, which you said that was the case. So what is the mechanism for the stars spinning in whatever you think? Because you said you don't believe in like the firmament and stuff. So
No.
you have the stars spinning above us. How is that causing the Coriolis effect on the ground on a hurricane, for example?
How is that? What? How is the Coriolis effect affecting the Earth? Basically, is your
a
question
hurricane?
a hurricane?
Yes.
There's
You
a
don't
lot of
know.
good questions and signs, right? Those are good questions. Like, so I'm gonna tell you. So, because I personally haven't seen no experiment that proves the Earth's motion, right?
Yeah, you've said that.
I've seen. I'm just letting you know like how I've gotten to this point, like why, right? So, that's
Yeah.
why I think what I think. So, I have no idea how those stars cause the Coriolis effect. I know there's math
Okay.
that Mach explained, right? That's what I'm saying. Like there's explanations from other people.
Yeah,
I don't know.
Hold
right?
on. Even the Machian principle doesn't provide a mechanism for how the stars spinning would cause the spin direction of a hurricane. No one has that answer. No one has that answer.
Right.
I've been asking that question countless times. No one has the answer. But we do have the answer.
Yeah,
We do have an answer that matches observations, specifically for hurricanes, for long-range sniper rifles, for long-range ballistics.
Like
Like,
ether drift, the drag, right?
no,
That's what we're
it's
talking about. We're
it's
talking about drag,
Coriolis. It's Coriolis, which is
But-
caused
but
by
you've-
the rotation of the Earth.
Yeah, so you've gone from
caused by the
Mach,
drag.
just like you've gone from Machian principle to then ether drag being the two different proposals for Coriolis, but they're not the same thing even to you. So which one is it
Right.
that you want to propose?
That's what I've said this from the beginning. I don't know, and I'm offering up different frames of thought that we're trying to answer these questions. Because if we're just gonna say something's right just because you have a good prediction model, we don't even know this is true, but we're just gonna believe this until the next thing comes along. That's not building. Like if that's
oh no,
not a fact,
that's
we don't know.
absolutely how you do it. It's a confirming thing, right? You have a prediction. This is
Right.
very very critical to have a prediction. And
Right.
neither ether ideas or Machian principles actually make predictions. And so that's a big problem for it. So when it comes to Coriolis, in all of those different things that Max mentioned, as well as multiple other lines of evidence, there is a mechanism that is predicted by the rotation of the Earth, right? It's an application of the conservation of momentum, is why if the Earth is rotating, then Coriolis must happen. It's a prediction that must happen, and it does happen. Awesome. And the magnitude we can confirm because it's been tested, right? The radius of the Earth and the rotation rate of the Earth has a specific magnitude of Coriolis. Guess what?
So the
Experiments confirm that.
momentum.
One more thing, almost there. And zero predictability by the other proposals that you're looking at there. Neither ether nor Machian principles has an actual prediction that we could go test.
What you're saying is very important. But, oh man, I had some, okay, all right. The angular momentum of the galaxies and the universe spinning will create that Coriolis effect, right? That's how they viewed it in Machian principles. And then the ether drag 15 degrees every hour. Honestly, dude, I don't know. These are questions that the greatest minds in science pondered, and we're still pondering today. As far as predictions are great. And I think if scientists took more time to study geocentrism, then they probably answer these questions, but that's not where all the funding is right now. And I'm probably wrong, and these scientists are right, and relativity is the right way to go. But I just haven't seen the experiment, so I don't want to use confirmation bias when I see data and just say, oh, this means this because of this, when we're just being biased. And that's probably a bad way of viewing things. I'm not really sure if this is a good way or not. This is just the way I approach things, and that's probably not good for science.
But this is science denial, and as you've said many times during this debate, that you're not the most qualified person to make the evaluation on whether these things are correct. Because, for example, here in the side chat of Zoom, I'm giving you 8 papers that all verify relativity. And for example, there is among those papers, time dilation measured in 30 centimeters difference.
Oh,
so
man,
that is huge.
I got videos and stuff like that. We could exchange information on that. But as far as the links you're sending me,
Max has actual measurements.
You have a
videos
paper. You have a video.
Measurements.
I have a scientific paper with an actual measurement of time dilation in a 30 centimeter difference. 30 centimeters.
It's about
because
a foot.
we are used to the idea of the quantum clock on the ground, the quantum clock high up. This is
because
30
you think time is a dimension that could be bent, and no one's ever proven that.
Oh, that's what I'm trying to show you. That yes,
that's what that actual experiment is testing.
The mechanism of the clock. That's the answer. But it's all right.
It's not a mechanism because it's not a mechanic clock. It is the atomic vibration of atoms. So, for example, I'm going to read you the paper titles. Space-time effects on satellite-based quantum communications. Testing the effects of gravity and motion on quantum entanglement in space-based experiments. Resolving the gravitational redshift within a millimeter atomic sample. Motion of gravity effects in the precision of quantum clocks. Gravitational time dilation, just 3 more. Gravitational time dilation in extended quantum systems in the case of light clocks in Schwarzschild space-time. Exploring the unification of quantum theory and general relativity with a Bose-Einstein condensate. A trapped atom interferometer with ultra-cold senior CRSR I'm sorry, the element SR atoms. Quantum frequency interferometry with applications ranging from gravitational wave detection to dark matter searches. So like this is the cutting edge of science.
Hold up. Wait, was it gravitational waves or gravity? Hold up. Say that again. What did they measure?
Quantum frequency interferometry with applications ranging from gravitational wave detection to dark matter searches.
Oh, okay. So they're assuming gravitational waves aren't the vibrational waves of the frequency of the thing. All right, I got it. So, all right, hold on. I got another question. How?
So you hold on.
Hold on. I have a
Are
question.
you no? Yeah. I'll let you do your question, but you're trying to debunk the paper based on the title
right. No,
without reading it. You're preemptively dismissing it because you don't like.
To understand, because I know what gravitational lensing is. But anyway, listen. How do you quantize gravity when it has no quantity? That's my question. And when you answer that, then I will be able to further understand the paper.
I mean, to further understand the paper, I think you should start by reading it, right?
There's a good idea.
Right. I just want to know, how do you quantize gravity so that I can understand this paper that you're showing me, quantum gravity in space communications?
Those are two separate papers, and it never talks about. It never talks about quantum gravity. So, just like I save the links, read the papers, and then we can maybe have another talk about that. And I've shared for the audience, if you want those papers in the chat, or you can request them from me on Discord, but I put them all in the side chat. They're super interesting. This is like the cutting edge of science right now.
I appreciate y'all giving me information, scientific information. I'm going to be nothing but smarter after this, hopefully. So thank y'all.
All right, I've got your $2. Almost ready.
Oof, let me send this text message real quick, guys. Sorry.
And I understand that you're on your phone, so if you want, Toon has the links. I'll remind him to send them over to you.
Yeah, can you send it to me on Facebook? Because I don't know if it is.
Yes, don't worry. We'll get them over to you.
I'm sorry, my pops texted me. I say he's in Puerto Rico. I'll make sure everything's straight.
Okay. This is.
All right, sorry, yeah. I'm sorry. Did you ask me a question or say something? I'm so sorry.
Are you a fan of the movie Better Off Dead?
Never seen it.
Oh,
that's too bad. That's
yeah.
Just I want my $2. Can you say I want my $2?
Oh, me?
Yeah.
I want my $2. I want my $2.
There you go.
Is this better than Bible quotes at least, or nah? You like the flat Earth Bible quotes better?
No,
let me know.
I'm not a fan of the flat Earth Bible quotes.
Okay, all right.
They're so wrong on that too, and I'm not even a believer, and I can debunk them on that.
God don't exist in no Bible or no book. Trust that. Trust that.
All right, I got a couple more things, and then we can wrap up here. We've got Harnold just sent something, but I'm gonna read.
Just forgot it right here, yeah.
We got Harnold said, "Go that way really, really fast if something gets in your way. Turn," which is another Better Off Dead quote. Icy Spin says, "Does your guest know scientists try to disprove?" In fact, that's the most powerful thing that scientists can do is disprove.
That's my
Did you know
favorite
that?
part.
Yeah. Okay.
My favorite part.
I see Spin says you may be shown an experiment, but you'll dismiss.
Not true. Not true.
All right, not true.
Not
There
true.
we go.
I might not
We've got it.
understand, but I will not deny it. I will not deny science. And if I am, that means I just don't understand it correctly, and just give me some time. But I will not deny science. So,
But that
there's another
clashes-
alternative.
You say that, but that
No.
clashes with what you attempted to do when I presented you with 8 like cutting edge papers.
I have to literally read these papers, and then I was trying to figure out exactly what you meant. Like, I was trying to figure it out. Like,
Yeah, but I was just reading you the titles of the paper. I wasn't making an argument or anything. Like, read the papers. If you have any objections, then we can talk about after you're done with the initial process that is required, that is reading the papers.
Right. I know y'all read the papers for 5 minutes here and think you understand it, but like it actually takes me time. Like I sit down, I read these things, like I try.
Yeah, no, we're not expecting you to do it live.
And hold on.
That's silly.
Another thing,
Yeah.
I want to address this because I appreciate all the information you're giving me. So I thank you, and I still thank you. Like I'm appreciative that you've given me this information. You're actually taking your time out. Like I'm not unappreciative of this. Like I don't want to come off that way at all.
And I mean, I don't have like a complete grasp. Like I can't do the math on the papers, but I try to get at least the concepts to a layman because I'm not an expert either. I'm just very used to dealing with flat earthers in the debate space.
All right,
Fair enough.
we've got another Better Off Dead quote. We've got, it's a real shame when folks be throwing away a perfectly good white boy like that. And then in the chat, oh my gosh, it's one of the best movies ever. Soul Watcher Paranormal says she only speaks French, Roy. She doesn't speak imbecile. If you haven't seen the movie, the French exchange student is hilarious. All right, well let's wrap it up. It's gone long enough. Anything you want to say?
Angel or me?
Angel, yeah. Then Max, yeah.
I appreciate the time and the opportunity, and I'm a student of life. I didn't come over here as an expert, nor was I trying to portray that. So on the low, I appreciate all the information here, and y'all don't have to believe it, but I'm gonna sit down and I'm gonna read that shit because I'm interested in stupid stuff like this, even if I'm not an expert or not. It's just what I like to do. So thank you for your time. Thank you for moderating, sir. And I hope we could, have a further discourse. And hopefully I'll learn a few things along the way because that's all I'm doing here is learning. Like,
All right, Max.
I have a couple of just like regular messages, and I took a couple of screenshots. Ernie Matthews said, "Toon and chat improve my life. Thanks, people, not you, Gary." NASA HR says, "Max, I'm sorry about the delay, but your check will be in the account at 6 a.m. your time. Thanks and sorry, Brenda from NASA HR." Rob Hoyle said, "I'm sorry, Max, but you do sound like a sober, intelligent Cheech in Dusk Till Dawn." And then Ernie Matthews said, "Max is new to me as a mod, and what a treat to see one that pays attention." Thank you so much for that. These weren't super chats, but they caught my attention. And then Ernie said that MCToon helped him improve his understanding of math, and I think that's super, super awesome. Thank you for those messages. This Friday, I will be on MDD debating Sal Cordova and a newcomer. I don't remember her name. I'm so sorry. And I will be tackling the topic of evolution. So if you're free on Friday, tune into MDD. I will be debating over there. Sorry. And then we will do an after show over at Matters Now, which the link is in the description. Thank you, everyone who is here. Thank you, Toon, for trusting me and inviting me. It's always cool hanging out with you. We always had tons of fun. And Icy Spin says, remind people of your marathon stream. I'm not sure if you want to do that now or you want to save it for later, but
yeah, well, I'll mention
it. I messed up.
No, it's okay. No, you didn't mess up. Yes, a week from Friday. Today's Wednesday, so 9 days from now, I will begin my 50-hour marathon. Fundraising for the trip to Antarctica. So if you got a little hoping that
you're doing that.
Yes, I'm going to Antarctica.
Good. Oh man, good. Is Witsit going? I heard he isn't.
Witsit has agreed to go and signed the contract that his legally adept self crafted.
Yes.
So,
wow.
Yeah.
So Jaren and Witsit is going. Lisbeth is going too.
Oh.
And potentially another flatty is going. Apparently, the announcement is forthcoming, as well as another normal is going.
But you said sellout. Are you implying that even that you would like to hold your position regardless of evidence, or what was that comment about?
I'm saying that he's a known liar. You know, they call him lying. So, you know,
well, yeah, he's a flat earther.
Right. So a big thing about flat earth and most of the models is the 24-hour sun. So in a lot of these debates, when it comes to the globe and the flat earth, a lot of these proofs are observations. But if an observation is impossible on your model, that counts for a lot. So, you know, a lot of these
falsification
trying to make
is what
models,
it's called.
right. They're trying to make models without it to compensate. And it's like, maybe you can do that, but it seems more like a cop-out, you know? So him being on the forefront of all of this, he should be the first in line saying, yeah, I believe it's flat and I'm going to go. So, yeah, like...
He took 3 months to think about it.
Yeah.
3 months from when he said, hey, I'll pay for you, before he's like, okay.
You want to know how long it would have taken me to accept a free trip to Antarctica?
That's just like 20,000. Give me that right now. I'm going.
Not 20.
I would have accepted in negative 1 second. Before I would have been offered, I would have preemptively accepted the trip.
It's 40,000. Because it's 30. It's 32 just to ALE once you're in. Once just to get on the plane from Chile to Antarctica is 32,000. But you still need to fly to Chile, about 1,500. You need to stay in a hotel, about 600. If you're sharing a room, you need to have get your butt out if you fall in a crevasse insurance. That's 1,500 or more. You need to buy all the gear, which is somewhere around 2,000. So all that together, I'm coming up with close to 40,000 as what I'm going to need.
That's a good estimate.
Yeah.
That's a good estimate. So you offered him a ticket, so you was gonna pay, and he still took time on that. Oh man.
Yeah, I have to raise my own money to do it. He's got it on a platter, and it's not just here. I'll pay the 32,000. It's I'll pay your flight down there. I'll pay your hotel. I'll pay your food before and after. I'll pay your insurance. That's
let me tell you
all
something.
Those things.
If I had to judge it just based off confidence, well, one side looks confident more than the other. Then that's the case. Yeah.
Oh yeah. I've said it. I will eat this whole Bible cover to cover, and I will stop hosting at Matters Now. So, Toon, if you want to put that on your page, because someone put me on the spot. I know it's a bit offensive to eat the Bible, but we all know nothing is going to happen.
Yeah,
but
you're
someone
safe.
asked me that on the spot, and I just looked around and I said, okay, what can I do? And it just came to me.
You're safe.
And
You're safe,
yeah.
man. All right. Well, thanks a lot, everybody. I'm gonna cut out. Don't hang up here in the Zoom call. But everybody, tomorrow night, 10 p.m. Central, might do a late stream with Sea Lion going over some Gauss's law for gravitation applied to an infinite plane. We'll see if how that goes. All right, everybody. We'll see you later.
What is a full moon and what is a new moon on your model?
Probably like a magnetic cycle, and just like the center of a barrel cell image of a magnet.
I think it's probably like a magnetic cycle, just like the center of a ferrocell spiral. Image of a magnet, it's just black in the middle. It's actually pure inertia, not just a little. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It becomes like etherically displaced. Yeah. You start to see it charge up once more, and it goes back like it did before. Once it becomes like etherically spaced, you see it charge up and take its place. Oh, shucks, ain't that so? That's how moon phases work, fam. Pass the dresser. In the magnet's heart, centrifugal divergence flies, centripetal convergence pulls. Defying all science, etheric whispers sing, light and shadow blend, magnetic cycles spin, where physics seems to end. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It becomes like etherically displaced. Yeehaw! Grab your partner, swing 'em round, magnetic cycles up and down. Either song in the air, hillbilly science everywhere, 'cause it's like etherically displaced. Yeehaw! Yo, belly on up to the Wixit word salad buffet. Who has light vinaigrettes? Behind the Jugger Ranch.
Then charges back up, and once it becomes like etherically displaced again, you start to see it charge up throughout a cycle, and then it goes back